Wait, yo, no, that was too fast. I wasn't ready. I wasn't ready. I thought you were going to ask me if I was ready. I wasn't ready. I thought you were going to ask me if I was ready. I wasn't ready. I thought you were going to ask me if I was ready. I have to change the name. I have to change the name. We'll call it Aside. A look into Nvidia open source drivers. Wait, I was not ready at all to start streaming. I just clicked that button. I thought it would come up with a thing. Oh, boys, I'm not ready. Oh. All right, we don't need that. No, we just mute that. Then we can turn that back on. This goes over here. We gotta get coffee. Oh. Oh, good morning and happy Saturday. This isn't coffee, this is water. This is water. You know, two fish swimming along in a tank. One fish looks at the other fish and says, hey man, water's pretty nice today, right? Other fish looks at him and says, what is water? Alright, we're getting coffee. Sorry for the delay. But we got things to do today. I also spent some of your subscription money. And I'll show you what I spent it on. We'll put a little cold brew in. We'll put a little milk in. And then we're going to read the Nvidia open source drivers. We're also going to set something up, but that's to be revealed later in the stream once we get some people in here. All right. Good morning. Everyone's filing in. Welcome. Filing in some. Whoa! Who's asking stupid questions? Good morning. Goo. You're using your Prime on me. Thank you. I appreciate you. I'll show you what I spent your money on. Don't worry. Your money's not going to nothing. Your money's not going to waste here. Here at the George Hotz Twitch Stream Factory, we're spending it on something good. Can I make my past videos not only subscribers to watch? No. Stop being poor and subscribe. Woo! Hype train. Let's go. Let's go. Good morning. Okay. So we're just going to get right into it. I prepared for you last night, okay? I prepared for you. All right. So first off, it turns out that tinyvoice works great. You just needed to train it on 8 GPUs for a day. It turns out that tinyvoice works great. You just need to train it. All right, so... It turns out that tinyvoice works great. You just... Oh, let's try it better. Tinyvoice works... Well, tinyvoice isn't a word, so that's not fair. We'll say it as tinyvoice. Tinyvoice works great. It listens. Tinyvoice works great. Tinyvoice works great. Look at that! Look at that, boys! Look at that! This is open source, by the way. You can try it. It works great. We don't believe in collaboration because it's stupid. We don't believe in collaboration because it's stupid. No major code changes since the last stream. I mean, you can read it. We don't believe in collaboration because it's stupid. Look at that. You got every word correct. Now, it does turn out there's a little bug, and if you speak too quickly, it can't fit enough characters in the decoder. But it's been a long, hard road without you by my side. It's been a long, hard road without you by my side. All right, so guys, I'm actually cheating. I got my friend Joey over there, and he's typing what I say and said, no, I'm kidding. It's real AI. I'd never do that to you. I'd never do that to you. We just trained for a long time. Yeah, but okay, if you talk too fast. Okay, but if you talk too fast, it doesn't work because it doesn't fit the characters in. See? I had to talk too fast, but I have an idea. I think I can do... Let's just slow it down, boys. Let's slow it down. Maybe we can slow it down. How do we do this? I think it's that one. So I think we do fake val equals, what is it? Numpy dot... what is it? Numpy copy access. What is it? No, repeat. Repeat, like Pete repeat. All right, cool. Repeat fake val to x equals 0. Yeah, okay. There you go. Okay, but if you talk too fast, it doesn't work because it doesn't fit 2 characters in. So it like kind of works if I repeat it, but this isn't actually a problem of tinyvoice listening. Here. Well, let me show you. I can show you quickly like how it works. So this is the model guess plot and guess dot shape. Okay. So let's plot mguess. Or you know what? I'll just show you something simpler. You can plot it too, but. See the problem? It doesn't have any room to fit in zeros. So like every single one is taken up. The outputs are too densely put together. Yeah. But here, let's talk very slowly. I like chicken. So I like chicken right there, and this is what it looks like, right? You can see. Let me make this big for everybody. See, this is the I like chicken, right? It's pretty good, right? And notice because I spoke slowly, there's plenty of room to pad it out with zeros. But in the other one, we speak too quickly. There's no room to pad it out with zeros. So this is tinygrad. This is tinyvoice. Tinyvoice works. Oh, that's something else we can do on a stream today. If we have many time for streaming, we can implement tinyvoice in tinygrad, because we do have good working speech recognition models. Now, we're not up to 1,000 people yet. Once we get to 1,000 people, I'm going to reveal what I bought with the subscribers' money. Tinygrad doesn't really have bugs. Tinygrad's pretty good. The new model's already on GitHub. I actually checked in this file last night, listen.py. So if we go over here to GitHub, yeah, I was messing with, you see this don't expand? So I was messing with expanding the linear layer and like making the final layer 4x bigger so it can output more characters. But I just set expand equal to 1. This model here, oh yeah, by the way, which got a validation loss of 0.11. I was excited with ones that, but you can see the truth here that everyone already knew. Bigger is better. I'm sorry, you know, I know that it's kind of going against the spirit of tinyvoice to be big, but it turns out that when you make the model bigger, it just works better. So what is the unreasonable effectiveness of very large neural networks or some crap? We gotta turn the cold down here. It is too cold for this morning. It is too cold. So 67, bros. No wonder it's cold. I like it cold when I sleep. Oh, why would I write this in Rust? Why don't we rewrite it? Hey, guys. You want to write this in Python? Or we could write it in Rust and it'll take 5 times longer. What do you think? All right, we're up to 620. That's pretty good. Once we get to 1,000, we're going to reveal what I bought with the subscribers' money. All right. I prepared something for you guys last night. It's called Q. All right. So Q is a computer, and it lives right here. I don't know why system restart's required. But Q's actually in my house. So let's take a look at Q a little bit. Q has a Ryzen. This is my gaming computer. Q has a Ryzen 5950. There's no such thing as GPU info. Q only has a pathetic 64 gigs of RAM. RAM's expensive, boys. I didn't want to buy more RAM. My computers at work have so much more RAM, but this one doesn't have much RAM. And my crowning jewel, oh, I hate that Nvidia SMI cuts that off. There we go. It's a GeForce, it's this one. It's a GeForce RTX 3080 Ti. I installed the latest driver last night, which should be the one that's compatible with the open source. So Nvidia did open source the GPU driver, and let's take a look. I want to create. What a tragedy. I was building Torch last night. I'm trying to figure out why Torch uses so much memory. Let's just make a new tmux. All right. This is a brand new computer just for you guys, prepared for this stream. Where'd my viewers go? Nvidia open source driver. I can't look at the viewer count. We're just gonna get viewers at some point when we're ready. Hang on, let me pop out the chat, like little Clay or whatever his name is. Pop out at your party, I'm with the gang, and this is gonna be a robbery. So tuck your chain, I'm a killer, gonna bother me. No, not mod view. Chat settings. How do I pop out the chat? Is there a button for that? Oh, everything's so hard. Computers are so hard to use. Click 3 dots, pop out of chat. Where are the 3 dots? No, those are channel points. What are channel points? Chat settings. Came in chat. Oh, pop out chat. Oh, chat settings. Thank you, bro. You're not a liar. All right, good. All right, we're in the chat. That's good. Yeah, all right, we're good. We good. Nvidia open source driver, GitHub. Here we go. The open-gpu-kernel module. All right, let's make sure my version is correct, first of all. All right, cool. So this version is this. So now I'm not running the open source one. So let's take a look at the open source one here. Okay, clone here. All right, how to build. Take modules jnproc. Oh, did that actually? I don't know how that worked. I think that's the ugliest syntax, by the way. I much prefer this syntax. Failed CC version check. Uh-oh. Probably doesn't like that I did that so many times. Okay, you know what? Git clean XDF. See how many processors I have. Wow, 32. Wow, that's a lot. All right, cool. Build the driver. To install, first uninstall any existing NVIDIA kernel modules. Note that the kernel modules here must be built with the GSP firmware. All right, wait, how do I uninstall the kernel? Where are my kernel modules? Where are kernel modules? even know which kernel I have. Oh, not D message. How do I check the kernel? Is it uname-a? I'll make it bigger for you guys. Oh, I probably updated. Hang on. Okay, I think we have to reboot first. How can I check if my new kernel's installed? Yeah, the new kernel's installed. Okay, should we reboot? If we reboot, is this going to ever come back? Or is this going to be one of these things that just doesn't come back? I don't know. How do I uninstall a module? Does anyone know how to do that? Okay, they're in there. Nvidia. I don't know. YOLO. Make modules install. Let's go. Alright. Didn't work. Yeah, okay. I think we have to reboot because I think we're going to get a new kernel. So let's get that time to just reboot. No. I'm doing this on another machine. Don't worry. We're on Tubby, and this is quiet. Well, either way, let's start reading the code. Guys, I can't afford a new computer. I didn't get enough subscribers for that. You can ping and wait for the machine to come back. Let me know. Let me know when you're back, machine. Let's first read the code of conduct. Oh, great. Glad we have one of those. Good. I know how to behave when I'm looking at the Nvidia drivers. So I think the basic architecture is, what's debug? Build the kernel modules as debug. Oh. Seems pretty nice. Okay, we have Nvidia, Nvidia DRM, Nvidia mode set, Nvidia PRMM, Nvidia UVM. And then we're going to start, we'll do a bit of a dive today into how CUDA works. And we'll learn what we can learn. Okay. All right, good. We rebooted. Do we have a new kernel? Oh, we have a new kernel. We're on 41 now. All right, that built fast enough, so we're just going to git clean xdf it and build it again. Make modules -j. I can just do -j. I don't know why I have to do -j on proc. That built pretty fast. All right, let's get a CUDA example going here before we install this GPU driver. Twitch. Let's call it CUDA. No, that's terrible. That's terrible. We'll call it, what should we call it? What should we call it, guys? What should we call it? You know what? This is kind of a part of tinygrad. The idea is that we're going to make GPUs fast, okay? We're not doing this for no reason. We never do anything with no reason. We're going to figure out why GPUs are slow, and all right. You know what? In the spirit of naming things, we're going to name it CUDA_example. All right, good? I've been trying to name things at work better. CUDA_example. And if you don't like the name, go to a different stream. Okay, here we go. Here's a simple CUDA example. What's saxpy? Example.c. All right. Cannot GCC it. It is not that easy. How do we build it? Ooh, NVCC. Oh, I have to save it as .cu. Wow, that was so easy to use. Can we talk about how easy that was to use? So easy. let's strace it and see if it's actually connecting to the You guys know strace? We're gonna learn some real reverse engineering skills today, boys. People are like, oh, I already know strace. This guy's washed up, man. This guy's washed up. The new kids now, they're using this tool he's never even heard of, man. Did we build this yet? We're gonna build it again. Let's build it again because we want to build it with debug. Debug equal 1. We love debug. Make modules -j debug equals 1. Oh yeah, good. Okay. So here it opens Nvidia control and it checks some block thing. It opens proc self status. Let's just put this into something. See, look, Vim does syntax highlighting for my strace for me. Alright, so here we're loading dev Nvidia control. Here we load Nvidia UVM. And here we connect to Nvidia 0. We actually open it twice. Now, remember that this isn't really, they didn't open source the whole thing. The only thing they open sourced was the kernel driver. So, but we can finally figure out how the kernel driver works, and we're gonna try to do it. So let's first take a look at SaxPy and figure out what it does. What does it do? Okay. It mallocs some stuff. It's like what is this? What is this? Does it say in here what this does? What's the name Sax mean? Why is it Sax? Oh, the triple chevron. Oh, good. Oh, there's a new, even easier introduction to CUDA. This one was too hard. That's a good point. Oh, that one makes you do it on not CUDA so you can appreciate CUDA more, I say. Wait. Is this even CUDA? Wow, that's wild. First, we have to turn our add function into a GPU function. Is this a good idea to put a loop like that on your GPU? It's going to be slow. I can't even use NVIDIA Prof anymore. You can't use this anymore because when you try to use NV Prof, it just complains and tells you that your GPU is too new and you need to go buy an older GPU. So you have to use the new shitty profiler, NCC. Oh, see, I told you. Think I'd lie to you about that? All right, good. We built that. Let's make modules install. We're probably going to have to sudo make modules install. Yes, but at least it's installing it to the right place now. Permission denied. All right, it's trying to install this. Should we just let it? Wait, that's not even right. Do we have to uninstall this one first? How do I uninstall it? Wow, look at all these modules. Why do I have so many modules? Okay. DRM. Well, we definitely don't like that. Okay. Let's figure out how to uninstall the module. DKMS uninstall module. How do I uninstall a DKMS module? Oh, here we go. DKMS status? Oh, perfect. Okay. Sudo dkms remove Nvidia all. Oh, not good enough. That didn't work. Gotta do a slash. This. You knew what I wanted to do. Oh, no original module was installed. All right. Did that work? Okay, no more. Not in there anymore. Okay, that looks pretty good. Now let's make modules install with a sudo. All right, all right. I don't know. Is this a okay error? Skipping depmod. Did we need depmod? Okay, we have Nvidia now. I think that if we ls mod, the old ones are still loaded, and we're gonna have to reboot again. All right, who's ready to reboot? Let's reboot. That's why I did it on a different computer. Oh, you're gonna go. I had to reboot anyway, guys. No. I do not want apt-get auto remove purge Nvidia because that's going to remove user space too. Don't remove user space. Okay. No, Nvidia SMI has failed. No, I hate that error. Okay, it didn't load for some reason. This is terrible. Oh no, we messed up. We messed up, boys. Messed up. No, don't, please, no. No. If Novu's loading, I'm gonna be so upset. Do I have my phone? Do I have your phone? I don't have your phone. Oh no, I have Novu. Okay, we gotta uninstall that. Is that what loaded? Let's check if it loaded. That's a good point, though. Novu. Why do they spell it in French? No, it's not that Novu loaded. I don't think anything loaded. Wait, but uh-oh. I don't understand. Okay. Wait. Mod probe Nvidia. Is that going to work? Module Nvidia not found in directory. LSPCI NVV. You're a subscriber. You know what's up. Oh. I did see something about Nova right there. This is pretty cool, actually. Here we go. For this VGA controller, which we know is this, kernel modules, Nvidia FB. Okay, let's insmod Nvidia FB. Mod probe Nvidia FB. All right. Oh. This is upsetting. All right, we're going to figure out how to fix this. Kernel driver in use. All right. Maybe, is there more? Which of these is NVIDIA FB? Oh, here's NVIDIA FB. Okay, I don't even think that's one of them that we built, was it? RM mod NVIDIA FB. Does that work? Okay. We unloaded the driver. Doesn't know who blacklists the NVIDIA modules. Bye. Yeah, we have 1,000 viewers, so I told them we got 1,000 viewers. We're going to show them what we bought with the subscriber dollars.
Oh, they're going to be so excited.
Oh, wait, we actually had 1,000? All right. Well, no. So you're going to have to wait. You're going to have to wait more. You're going to have to wait. I'm not missing any files. I don't understand why this doesn't work. But that's what we're here to discover, man. If everything just worked, what would be the point of life? You know? Life's about shit not working, man. You know, shit, man. That's, never mind. We're not doing any more of that kind of things, you know? You all want to hear, like, things. We're not doing that anymore. Okay. Is this this isn't the problem. The problem isn't because it's signed, right? Missing system map file, skipping det mod. Is that the problem? You can run det mod after the modules install. Sudo det mod? What does det mod do? Well, let's read the man page. Okay, that didn't help me. Sign file. Cert signing key.pem. Well, the keys need to be created. Leads to error. All right. Let's make a key. What? I don't understand. Oh. Okay, we have a signing key. Let's see if that fixes that. No. Oh, we don't have an X509 signing key. I thought I told it to make that. Why didn't it make it? Oh, because it didn't find a distinguished name. Unable to find distinguished name in config. But there is one. Oh, this didn't work. Who wrote this crappy echo command? I'm gonna do en. It's supposed to be fun, turning 21. All right, good. All right, we have both keys now. Let's try that. All right, oh, look at that. That's pretty good, okay. Now they're signed. I don't know if that's what's gonna fix it. Missing system.map. Okay, how do I get a system.map? This is a warning. That's not good. Okay. But it still seemed to work. Yeah, it was just a lie. Nvidia is not really open source. All right, I still, what is, oh. Oh, okay, depmod ran. I don't know. Is this better? You think if we reboot now, it's just gonna work? Oh, look at that. It hangs now. Oh, look, we have stuff. Of course, Nvidia SMI doesn't work because it hangs. No, I sudo depmod and then it worked. Okay, we just needed to sign it. Okay, that wasn't too bad. Okay, well, we tried. Let's see, is anything in dmessage? Ah, here we go. Look at this. Ran out of a critical resource. Right, let's just reboot again. Oh, this might be a GSP problem. We might just need to get the GSP. I don't know what a GSP is, but we probably need it. All right, guys. Are we really at 1,000 viewers, or are you trolling me? We are at 1,000 viewers. All right. The reveal of what I purchased. We'll try app install GSP when we reboot. The reveal of what I purchased with your money. I got an email from a subscriber. And they had an idea. And sometimes you come up with good ideas. I bought this with your subscription money. To anyone who said I was rich, that's a lie. I lost it all in BitConnect. I used to be rich, and then I gambled on BitConnect. They told me it couldn't go down. Just when I was starting to rebuild, I put all my money in Luna. They told me it couldn't go down. And, well, it went down, and now I'm poor. That's why I'm back on Twitch streaming for you guys. I also, never mind. Regardless, I'll show you what I bought with your subscriber dollars. This was a suggestion from a viewer. Where do we have more data that matches audio with voice in the world? Even better, it's beamed to you for free over TV. I bought a quad 4HD ATSC digital TV tuners for USB. You know it's good because they put an exclamation point in the product name. Look at that! Exclamation point in the product name. 4HD ATSC digital TV tuners for USB. All right, and then I also bought in this box, let's see, an antenna. Whoa! Amplified HD digital antenna and USB. And we're gonna try to use this later on stream. But for now, we're gonna try to get the Nvidia driver to work. All right, Nvidia SMI? Okay, we're not there yet. Okay. Direct ran out of a critical resource. Well, all right. GSP RM control failed. The good news is I think we can read the source code and see what's going on here. What happened to my other window? Here we go. Where was that? The window can go here. All right, here's the problem. What was not okay? What is this function? RPC RM control GSP. I did read something about the GSP. So we're gonna need to deal with it. I'm glad we built it with debug, okay. Make sure the kernel modules built here must be used with a GSP firmware. All right, so let's download Nvidia Linux download. Let's just look around. Is there a GSP somewhere? Is it in lib modules? I didn't delete anything. I just dkms removed it. I don't think it's that GSP. Okay. Latest beta version. Is this gonna work? Hate this. Dude, why would I ever want to download confirmation PHP? Nobody ever would. All right, download. Is this the real download link? Yes, that's the real download link. All right, fine. Let's go. This can be achieved by installing the driver from the run file. No, I want a real dot. Oh, okay. Here we go. We have this. It's in libfirmware Nvidia gsp.bin. All right, so we have a GSP. GSP RM control failed. Direct firmware failed to load GSP. Oh, okay. Well, it's good because this is still okay. Open Nvidia is only ready for use on. Oh, we have to do the is only ready for use on data center GPUs. Ooh, they have some docs on the GSP. All right, let's take a look. Okay. It seems pretty good. But wait, does this really only work for data center GPUs? Open Nvidia KO is only ready for use on data center GPUs. Let's read if this is real. Oh, it checks the branding. Great. Oh, go to shutdown. Oh, we don't want to go to shutdown. Oh, that's the problem. All right, well, let's not go to shutdown. Let's figure out how to set the OpenRM enable unsupported GPUs described in the README. Oh, here we go. Oh, all right, here we go. This guy, PyMaker, is a bro. All right, let's go into Etsy mod probe D. It's in the README. Let's try it. Works on your 3060? Oh. On nvidia.com. Oh, it's gonna complain. It's gonna be like, yes, it's not. When you say, yeah, read the file, yeah, we have a sudo. Why is this a bad choice? You make bad choices, and you shouldn't make bad choices. All right, good. Thank you. Sudo mod probe NVIDIA. Sudo, okay, ls mod. Ls mod grep NVIDIA. Sudo rm mod NVIDIA. Does this actually work, or do we have to reboot the computer again? We have to reboot the computer again. Okay, we made a file though, so this is progress. It works on your 3060? We need more coffee. Oh, yeah, no. We didn't use a transformer, we used a conformer. It's a transformer with a convolution, and it worked great because the model was really big. And it turns out only two things matter in deep learning: how big your model is and how much time you trained it for. Oh, also how big your data is. If you make your data bigger and your model bigger and your training time bigger, your results get bigger. Someone should just, that's deep learning right there. If you think you know something else about deep learning, about, oh, the architecture matters, you gotta try atom W with weight decay if it doesn't matter. Only 3 things matter. How big your model is, how big your data is, and how long you let it train for. Nothing else matters. Oh, no, okay, we got a new error now. Uh-oh. Is this okay? Maybe it's okay. Ooh! It worked. Okay, we have Xorg and GNOME shell running. It's pretty nice. All right, let's go back to our CUDA example. SaxPy. It works. Let's see what came up in dmessage. Okay, all right. We're still getting some errors with the GSP RM control. Probably not important. Yeah, we can use non-data center GPUs with a one-line workaround. Okay. I mean, the other thing that I wanted to do was look into why Torch uses... I tried to build Torch last night, and it didn't go well. So we'll just go back to this. No, I think it mostly went okay, but it just took a long time. I like Torch because it gives us precise control. What's the reason I'm doing this on Quiet, not on Batman? Because I don't want to break Batman. We actually have to do work on Batman. Quiet is just for playing games, and that's what we're doing right now. Oh, I like this one. Python is Python 3. Let's install it. Bro, now I can type Python. I love that. I love that. Python is Python 3. All right. So you'll see now we don't have anything, but if I type torch.zeros2.cuda, we now have a thingy on the GPU, hopefully. Okay, good. Unfortunately, look at Torch. It uses 200 and so many gigabytes of memory, and it uses lots of gigabytes of memory, but CUDA 11.6 supports lazy module loading. So, yeah. You can do this with CUDA model loading equals lazy, and then it uses less. Never mind, that doesn't matter. Okay. Wow. Is this what I get for building with debug? Tons of spam of GSP RM control failed. Let's learn what this is by reading the code. Oh, this is like some RPC thing. Okay. All right, good. We understand what the GSP is. Let's go back to the documentation for the GSP. I don't know where that went. GSP documentation. Video. Here. People say Google isn't good. You want to take a look at the GSP? Let's see what the GSP is. What is it? User. You shouldn't type find to grep. You should memorize the 17 weird parameters of find. All right. Wow, 39 megabytes. And it's like encrypted or something? Is it encrypted? Whoa! RISC-V? No, it's not encrypted. This is real. Wow, the GSP chip is RISC-V. That's cool. So you're telling me Nvidia has a... GSP firmware version. Cool. All right, now the question is, what was this command supposed to do? We should be able to find the GSP's API here. Let's find the things that call this, and let's see. Oh, great. The RM API. All right. PRM API. So we have to look for things that call control. Here we go. No, not that. Oh, here we go. Here are the commands. Oh, perfect. Now we can figure out which command's failing. No. Nope. Can't find out about that command. This command failed too? Oh, here we go. Control command get. Oh, well, no wonder this one failed, because this isn't even a real command. I don't even know where it got the idea to send that command. It's got to be in the driver somewhere, right? Control get offline pages. Wow, this is pretty cool. This is super nice. NVIDIA's good guy NVIDIA. Right, so does everyone understand what the GSP is? It's like a little firmware that you can offload things to, and this is the documentation for it here. What's the FB engine? I think it's frame buffer, but I don't know. Control 2080. Oh, is this because it's 2080 like that, 2080? Where's 2080, right? Where's my VGA compatible controller? No, it's 2208. Well, either way, these things are all... Yeah, they start with 2080. So it must be using these commands. How does it know which one to use? Or maybe these are all failing because my monitor's not actually plugged in. It's the same monitor that I'm using here. What? Infringing? I'm literally reading open source software, boys. If NVIDIA has a problem with that, they shouldn't have made it open source. No, look, NVIDIA's not the bad guy anymore. Let me explain why, okay? And I know that, like, oh, we're not explaining anything anymore except we're doing software, but, like, look, this is NVIDIA's share price, right? When NVIDIA's share price goes like this, they're dicks. When NVIDIA's share price goes like this, they're nice to people, right? This is just business 101. When the share price goes up, it's good for the shareholders and bad for the customers. When the share price goes down, it's bad for the shareholders, but it's good for the customers, right? So every time the market crashes, you should be happy because companies are going to try harder. This is a fucking joke. Wait, this is a fucking joke. I can't stand this shit. Right next to their market cap is a measure of actions a company takes to address climate change. Bros, I don't want to talk about this, but Google, you shoved it in my face. Look. I'm just going to say this. Elon was very correct to point out that you have your environmentally sustainable governance, and Exxon's on that list, and Tesla's not. So it's what is it? Jesse Jackson. It's the push coalition, but for carbon. You got to bribe the carbon guy, man. Yo, I got the carbon guy. Yeah, no, man. I sucked his dick last night. That's why I got a CDP score of an A, right? And that's what it is, all right? So this is unbelievable. Like, fuck Google, right? Google, why do you put things like this here? It's just, oh, yes, I can learn about CDP scores. Oh, you even put a link on it. Why can't I learn what a market cap is, you know? Why can't I learn what a PE ratio is? Huh? Why can I only learn about your bullshit? All right. Sorry, I was triggered. And it's designed to trigger you, okay? Agitation propaganda. And it's so effective because I'm agitated now. All right? Agitation propaganda. Remember that phrase. All right, let's get back into not being triggered by Google. Does Yahoo Finance do this? Would Yahoo Finance do this to me? Oh, look, it isn't video. Wow, Google's up. No, Yahoo Finance is not. Oh, they're overvalued. Yeah, it's good. The price can go down more, and they can open source more stuff. Guys, you can't. Let me show you guys the future. Let me take 1 second to show you guys the future, and it's this. All right. Do you think like? These people do understand that when they don't put Tesla on the ESG list, they don't delegitimize Tesla, they delegitimize ESG, right? They delegitimize this whole idea. And look, let me tell you a quick way to promise that your shit's going to be replaced. And that's to try to shove your ideology into it. And I really, when NASDAQ and Dow Jones and all these suit-wearing, sexual harassing Wall Street motherfuckers, when they get BTFO'd by the crypto, you're gonna know why. And you heard it right here on this stream. So that's what's gonna, look, man, let me tell you, freedom wins. Freedom wins. And I didn't want to go on a rant, but Google, you triggered me. And let me tell you, I hope you guys all know, really, you gotta keep the CIA out of your head. You gotta keep these narratives out of your head. You gotta stay focused on what matters. And that's, don't try to fight them. Don't be a Republican. Come on, Elon, don't be a Republican. Oh, you're not, man. Oh, yeah, you know what? I think the Yankees suck, so I'm going to go be a Mets fan. No, the problem is you're rooting for a couple of guys, grown men, who throw a ball around on a field. That's the problem. The problem isn't that you root for the Yankees, or you root for the Mets, or you root for the Dodgers, or you root for the Kansas City Royals. The problem is that you root for a group of men who throw a ball around on a field and get paid millions of dollars to do it. That's the problem. All right. All right, where were we? Oh no, oh yes, oh it's the two-party system, man. It's the two parties. Imagine we just had more teams. We gotta let more teams into the league, man. We gotta let more teams into the league. We have more diversity, man. No, grown men throwing a ball around. Okay, the thing that we really wanted to get to the bottom of. But now we can like read this. How well documented is Nvidia's like their API for what I'm wondering is, all right, so we have this CUDA example, and like, what API is this actually using? It does. I feel like I've looked into this before, and it doesn't look like it's I/O controls. Maybe it is these I/O controls. Or maybe it is these. All right, let's figure out what these I/O controls are. So I'm opening dev NVIDIA 0. There's like a comment, it's like IOWR. What does DRM stand for? I don't think it's digital rights. Oh, direct rendering manager. So maybe these are the I/O controls that actually, but see, it doesn't know what they are because what's 3? Use a socket. Oh, it connects it to MPS control. No, that went away quickly. Proc modules, not that. Oh, it's NVIDIA control. Okay, so these are NVIDIA I/O controls. Let's see if we can get a list of them somewhere because it is using I/O controls. We should do our best to keep these values constant. Okay, these are the NVIDIA DRM I/O controls. I don't think we opened the. What does the direct rendering manager even do? Direct rendering manager is a subset of the Linux kernel. Okay, not important. So what exposes NVIDIA control? Is there any documentation that tells you kind of what these things are? Okay, what's the UVM? Unified virtual memory. All right, that seems useful. NVIDIA KO exposes NVIDIA control. Actually, is there a way to like look that up? Can I see which module created which file? I mean, maybe it's the major device number. Lists dev major device numbers. I think there's some way to do this. Oh, here we go. Proc devices. Oh, sweet. Oh, this is sick. All right, cool. So 195 is Nvidia front end. I don't know who makes Nvidia front end, but still, it's pretty cool. Oh, look at this. I can get this book for free. Wow, this pop-up really appeals to me. Sorry, I'm still triggered. I'm still triggered. We gotta do some meditation, man. We gotta do some meditation. Agitation propaganda, you know? Ooh. What's in the Nvidia proc? I was looking at this last night. All right, subscriber only chat time. We're going to try to figure out what these I/O control. Okay, we have a goal for the stream. Let's discuss our goal for the stream. Our goal for the stream is going to be to do a CUDA operation from a C program. So instead of using all of NVIDIA's stupid drivers, we're going to try to not use the drivers, and we're going to try to, just do it with raw stuff. So then we can have a completely open NVIDIA stack. We have an open source driver and everything open source. Novu, I'm sure, is going to switch their user space to start using the real NVIDIA driver. I know there's some clocking issue with Novu. I don't know if the open source stuff helps with that. But either way, let's see if we can do this. So I did something similar in OpenPilot. It's called Thneed. So we go in OpenPilot in Model D. I wrote this thing called Thneed, which is an I/O control interceptor. And it sits here and it grabs these, KGSL is the Qualcomm GPU, and it grabs the I/O controls from the GPU, and it caches them so it can replay them later, and then it doesn't use any of the user space driver when you're rerunning the model over and over again. Okay. By the way, now I really want to do, I was making fun of your share price, but I really want to give a shout out to NVIDIA for open sourcing this. Look, if companies are thinking on a long-term time horizon, this is a brilliant choice. I also saw some specs of the 4090, and they look amazing. Like please don't nerf them in any way. The number on the 3090 that I just couldn't believe. So first off, that's a wild TDP, but you know, that's not. Do they have the number here that I couldn't believe? No, I don't think they have it. But this is the new, 16x L2 cache. They're putting 96 megs of L2 cache on this chip. We're finally going to be able to fit decent-sized matrix multiplies in cache. For reference, the A100, the big difference between the A100 and the 3090 is that the A100 has a 40 megabyte L2 cache. The AD102, which hopefully is going to be a normal consumer GPU, is going to have 96 megs of cache. Like, you just, when I see this, give up ever competing, like nobody's going to compete on deep learning for quite a while if these specs are real. Like, yeah, you'd have to take a different architecture. Maybe Tenstorrent's doing something interesting. But again, I haven't seen a chip from them. NVIDIA's going to ship these things. They're probably going to be more available than the last one. Like, I'm so excited for this GPU. And yeah, NVIDIA charged $2,000 for it. Like, when you charge 10 grand, you're gouging. But when you charge 2 grand, like, shit, you could charge 2,500. If you charge 2,500 for this GPU, everyone will buy it. 103 teraflops. And with an open source driver, open source your user space too. Why does it matter? Open source your user space. Don't open source your chip. Keep your chip closed. Just make your chips available. You'll sell so many of these. You'll own the future. You will own the future of AI if you do this. Nobody's going to compete. But, you know, yeah, good on NVIDIA for open sourcing this. All right, sorry. We're gonna talk for one more minute about why I'm really triggered by this. So what these people are trying to do. When you look at the market cap and the PE ratio of a company, these are capitalist metrics, right? What these people are trying to do, these people are not capitalists. This is not a capitalist goal. Right, these people are trying to put in, and you know they're pretty open about this. They're pretty open this idea that they want to subvert capitalism and replace it with something else. And like, you know, I don't think they win. And what's really sad about this is like this doesn't win. It's openly mocked. Everybody knows what a joke it is. It's not gonna. Nobody in 20 years is going to seriously be like, oh, well, the CDP score of the company. No, I mean, it's just not going to happen. But they throw away, like, good institutions that have been created. Institutions that arose not out of a goal to, like, engineer society, but out of a goal to, you know, accurately reflect. You can do two things. You can build something that tries to reflect a true metric and put a number on it, and this is like doing science, right? Like if you the concept of a market cap of a company is, and I think that this is the fundamental epistemological error of these people. They don't believe that there is a true underlying reality. And, you know, I'm a postmodernist, and you can say a lot of stuff about this, but you can't deny that there is, that something like a market cap is fundamentally real in a company, right? Like, you guys everyone understand what a market cap is? It's just the number of shares times the share price, right? You don't have to represent a market cap as shares. You can represent it in a lot of different ways. But you have this fundamental idea about what the company is actually valued at, regardless of what you call it. And when you build an institution that reflects, like, what the thing is, it reflects the underlying, that's an institution that is aligned with truth, and that's an institution that will grow. When you try to use the goodwill of the institutions to push things like this, you don't get this. You get a weakened institution. And that's the really sad thing. The really sad thing is this isn't going to push climate change stuff. This is going to destroy NASDAQ. And maybe it was inevitable. But revolutions suck, and you don't want to live through them. I don't want to live through a revolution, at least not this kind of revolution. I don't know. Some parts of it'll be cool, but I would rather I'd rather not. So that's really why it upsets me so much. A market cap is like KVA. It's not the true power. You can talk about taxing externalities all you want, but that's not taxing externalities. You can tax externalities. I think that's generally a good idea. But that's incredibly different from what that is. Right? Taxing externalities is capitalist. There's nothing not capitalist about saying, hey, wait a second, there's this cost you're not accounting for here. We're the government, we're going to account for it. That's fine. If you want to do that, that's actually good. But if you do this correctly, it can all be reflected in the existing true metrics. Let's really try to. I don't know. I'm excited about the new GPUs. I listened to Martin Shkreli's live stream last night. He was very dull. It's very dull. Good on Shkreli. JL really reformed. He's out. He's out. He's in a halfway house now. Kernel open common ink. How do I turn these I/O controls into, let's see, list of Nvidia I/O controls? No. Just GPU direct. Actually, this might be a universally good tool if I actually write this. If I write something that just you can LD preload it, and it sniffs all of the I/O controls that are running. I'll show you how to write something quickly. All right. So let's call it cuda ioctyl sniffer, because we're not giving anything clever names anymore. We're done with clever names. We're just calling it cuda ioctyl sniffer. Sniff.c. Ioctyl. We can just copy this with the need. And you know what? We don't need to put it in its own folder yet. We'll just put it in CUDA example. Sniff.c. GitHub, ComAI, OpenPilot, need. That's already C. We don't need that. So what we're doing here is we're just going to build a little library that oh my god, really? Reinterpret cast. All right, fine. We'll build it in C++. Pop out at your party, I'm with the gang. This gonna be a robbery, so tuck your chain. Clang. Tiny Sniff. No, he went on Twitch Spaces last night. Twitter Spaces. Use of undeclared identifier null. Which is null? What do I include for null? C string? RTLD next. Need define reference to. Alright, we don't have main. That's because we have to build a library dash shared. Compile with fpic. We'll rename it a.out. Let's say run.c is just this. Call it sniff.so. And then we can run ld preload sniff.so./saxpy. ld preload. Why can't it be preloaded? Cannot open shared object file. Great. Okay. Let's throw printf in here. Ew, who calls it file des? Okay, cool. So now we're printing out all the I/O controls. How many of these are actually going to Nvidia things? We could intercept open as well, or we can just do it with strace. I really want to link in You found it? Is it this? Where was that being defined? Here we go. All right. Nvidia iOctal base magic. You think it actually is this? What are ESCs? All right. Well, the magic is F. So what is F? Ord 70. Hex ord, is it 46? Okay, fine. So it is 46. And then, okay, the base is 200, so this is the number here. What's 200 in hex? C8, okay. All right, so that seems right. Let's just look up the IOWR iOctal. Like, there's like a way these things work. Type NR data type. So this is data type. This is the length of the data. This is the magic, and this is the number. So like this C9 is a register FD, and this CE is what's E? E is 14. 14 minus 8 is 6. So this is a ALEC OS event. Okay, okay. That seems pretty sensible. Great. All right, let's link that in. So build, let's just link that. Add -I GPU kernel modules. No, it's not what I wanted to include. I wanted to include Nvidia ioctal numbers. All right, Nvidia ioctal numbers. If request and ff equals, so this is register fd. If request shift 8 equals f. Actually, we can just call it NVI octal magic. Don't have magic things. Oops. Okay, you know what? Let's just break this out. ioctal. I just had it. They're like called something. Here we go. NR type. This is the data type. Okay. Type equals requests. All right, pretty cool, right? Which one was the other one we were using? CE, so E is 14, so that's plus 6. So alloc OS events. All right, pretty cool, right? So I think these are all NVIDIA things, but no more of these, because these all start with 200 and they would be like 7C. So, oh, okay, C8. C8's one of them. C8 is a card info. Wait, this is also C8? That'd be card info as well. Oh, did I not? Oh. Refactor. D7, that's going to be C8 plus that's 15, but no 15. Okay, we don't know what that one is. D6 should be sysparams. D2 is check version string. Oh, we'll just do them all. This won't take too long. Like OS event, free OS event. And no, we're learning while we do this. It's not a good idea. Okay. So D2 is 10, so that's check version string. And we don't have D7 for some reason. It's just not here. Okay. Let's figure out what 2A and 2B are. So this is probably defined in more places. Here we go. It's just the same. What are these ones? Yeah, this is going to the same place as these, I think. Did you find any others? They have to be, okay, these ones have to be in there. We can get to parsing them, but I want to understand what these are first. Maybe they're just generic I/O controls? No. 46. Okay, and you see this? This is the length. That's a length argument. That first C is read and write. We can figure out how to extract that if we want to. You want to extract that? Let's extract that. Okay. It's a 13-bit or 14-bit. Just do that. It can't be bigger than that. See? That tells us the length of the parameters. Let's add some prints to our saxpy. What? Okay, well the communication's clearly not over ioctals. See the problem? Oh, well I guess, okay, we did the malloc somewhere else. Maybe that's just... Maybe that's just a knit. Maybe that's actually just calling all the fancy init stuff. Okay, well, it did something for the malloc, but okay, these ioctals aren't actually doing anything, which kind of sucks. Like, what's triggering the launch? Nothing. Okay, how is this thing communicating to the driver? It's got to be memory mapped IO, right? Follow NV status RM ioctal. Oh, this is just this stuff again. Where are the other ones? Oh, here's more. Okay, cool. NV escape. All right, cool. Well, at least we can define a few more of these, so it doesn't hurt. Where is this in? Source, Nvidia, Arch, NV alloc, Unix, include NV underscore escape.h. Okay. Main ones. Escape. Good find. Good find. Good find. Okay. Good. We have some alloc memories. We have some RM allocs. What's 2A? Some RM controls. Oh, cool, they're all here. All right, we have some RM map memory. Ooh, that's exciting. Oh, that is exciting. Oh, we love map memory. All right, cool. Look, we're like filling them in one at a time. We have vid heap controls. All right, do we get them all? We still have this one, D7. Yeah, we just said we're not going to figure out what that is, and we have a free. Let's sort these a little better. Free. All right, cool. Great. Great. We have all the ones except for D7, which we don't know what it is. How come we don't know what D7 is? But bro, finding this, good job. I'm proud of you. All right. Everyone can talk again. Only if you say good things. Gotta be. It is plus 15, right? Never mind. I hate all of you. Subscriber only. I'm upset. Like, how come I don't know what that one is? Version string. Oh, here we go. It's in Numa. Oh, we gotta get Numa. Okay. Kernel open NV ioctal Numa. Numa ones. All right. We have them all now. What? No. That was right. That's D7. No, that has to be D7. Don't D7. What? How's that not? What? That's that one. Is it not F or something? Yeah, but no, it's this one. I found it. Oh, it's because NV Linux isn't defined. Wait, I don't even know how this built. Oh, it didn't build. Oh, I see. All right, fine. Always throw some dash E's on that bitch. All right, good. We got dash E's. All right, use of undeclared identifier. And it's because we didn't define. You know, you always waste time thinking your shit built when it didn't build. All right, great. File not found with angle. Use quotes instead. Great. Problem solved. So it must be using some memory mapped IO stuff. Because it's not even in. It must be, yeah, it must totally be some user space communication thing because it's not even in. And I feel like I looked at this before and found the same thing. So I'm not even sure how we're going to debug this. You do it in, you want to do GDB? What do you want to do? Does anyone have any ideas? If I let non-subscribers talk, are you gonna have any ideas? By the way, you want to see something cool? So we can now LG preload this and like load up Python. And we can like import torch. And we can do torch.zeros.cuda. And you'll see, look, it calls all this stuff. Ooh, that called vid heap control a lot. This does kind of actually answer the question I care about, which is actually where's all the memory going? All right, let's look at vid heap control and see what it is. B8 NVOS2 parameters here. Wow, that's a lot of parameters, boys. Oh, it's a union. Hate the unions, man. Function, all right, so it's a function Alice Oss descriptor. I did not call it date, I called it argp. Unknown name. What do I have to include for this? NVOS. Source common SDK Nvidia Inc. NVOS.h. Oh, common. Is there another NVOS in here? No. Cannot initialize it with an L value of void P. Well, because we don't code in loser C. We use C++, where types are respected. Oh, jump bypasses. Oh, I hate this. Oh, this is why you don't use switch statements. Great. All right, is that an alloc os descriptor? No, it's not. It's an alloc size. I think. Whoa. We're using ranges. PRX data, alloc size, H memory. Oh, this is so hard. Where does this alloc size come from? What is alloc size? Oh, it's in here. Okay, cool. So I think we can just, how did that? Where does this get allocated? Oh, must be some like hack. All right. Oh, it's gonna bitch at me again and tell me I can't do that. Wait, what if I throw some brackets around that? Does that fix it? Oh, brackets. Oh, yeah, yeah. All right, now we're talking. We got brackets. Yeah. Now I can print things like type. ASZ dot type. Okay, well the type's always 0. That's good to know. Does it have an owner? Good owner. You're a negative boy. Oh good, that's the owner. Do we have flags? Let's see if we have flags. Do you think we got flags? Flags are definitely a hex kind of thing. Cool, we got some flags. We got a height and a width. Is this boring? C should have macros to generate this stuff. This is something I love about Python. Everything's just fast. Do we have a size? Oh, we didn't do the width. Oh, that's pretty good. Okay, so the size is hex 40,000. Does that match? N times size of float. Yes, it does. All right. Okay, we found the malloc. It's vid heap control. And this is the other malloc right here. Oh, look at that. BB8. That's a lot. Why are you mallocing so much crap? Smurfy, thank you for gifting subs. You know I appreciate you. Look at this. Oh, look, we're allocating 196 megabytes. We found where all the megabytes are going. Oh, we're going to use so many less megabytes now. Now that I found the megabytes. Oh, watch this. Oh, this is cool. This is cool, boys. Look at this, look at this, look at this, look at this. All right, now when we import Torch, one of the problems that we were trying to address with this is the fact that Torch uses so much memory. Look, I'm gonna make an array in Torch, and it's just 1 0. It's just one pathetic, measly 0. I'm gonna copy it to the GPU, and then look, my GPU is using that many gigabytes of memory. We're using 2 gigabytes for 1 0. What is all this 2 meg crap? It's not even the problem. That's only 2 megs. Where's the real megs? Can't even scroll back far enough to see the real megs. Let's make a big one. Bigger? Oh, look, we had to allocate. Look at that. We had to allocate when we did zeros. That made 20 megabytes of zeros. But why did we take 2 gigabytes? That is the question we will answer today. And that really solves my problem, because at Comma, we bought cheap GPUs and then we have a low memory, and I'm trying to shove lots of, no, you'll see what we're doing. It's a site, guys, we're actually doing work for work. Oh, yeah. Wait, but how's it allocating that without doing more? Let's make it bigger. Can't get out of that. There we go. Look at that, 67 megabytes. Oh, yes. Print Torch CUDA memory summary, got it. But it doesn't tell you where it's using the memory, right? Okay, you can look. Allocated memory, 64 megabytes. Yet when I look here, it's using 2.1 gigabytes. I don't even understand. All right, well, we don't need any of this stuff, because all this stuff was useless. It doesn't matter the size. Where are the big things that aren't 2 megabytes? Okay, well, let's allocate 1,000,000 2 megabyte things. See, nobody's looking on this level, you know? Back in the day, people used to respect the hardware. Now nobody respects the hardware because they're just like, we have so much of it. All right, well, look at that. The first thing this thing decides to do is allocate 4 gigabytes. There's 196 megabytes. Does it give that back? Function alloc size. Okay, maybe this is just a heap. So I don't understand. How did it allocate for? What's RM control do? Don't you love that we can read this now and like see? Okay. So I'm doing the simplest CUDA thing. This must be allocating context, right? Let's break things up a little bit. There's like a CUDA init, right? By the time I'm using CUDA malloc, this is actually a pretty high level API. There's 2 APIs to CUDA. This is the CUDA RT API, but there's another one, CUDA contexts. It's the CUDA driver API. So we can like create a context here. Flags, no flags. Do I have to really get the CUDA device? Yeah, I probably do. Device management. CUDA device get. Because I think that's what's actually going on low level in this driver. I don't understand. Oh, I commented that out. These things are undefined because we have to include cuda.h or something. In function main, unreferenced. Oh, we have to link it? Okay, cool. No, none of this stuff does anything. Does that create context call failing or something? Let's read some example code. No, it seems okay. Oh, I have to call cuinit first. Okay, cool. Check it out. So now entry malloc has moved down here. So this is all in the context creation. This is nice. All right, good. So here we go. Getting the device is free. All right, when we do the init, we're doing this, but I'm sure there's some flag set there that actually makes it useless. We should take a look. Let's see. Okay, so all those flags are those, but if we go up here, look, it has different flags. I knew it was fake. So this first allocation is fake, but these other ones are real. And we're going to try to figure out why. Okay, so let me explain the real problem. We have computers at work now. We put in T600s, and the T600s are, they don't have that much memory, and I'm trying to load I'm trying to have 12 processes just use them. So Kafka's right here. It's like my local machine. I'm trying to have a whole bunch of things just use them. And in order for that to work, oh, we forgot one. Oh, we forgot one here. Let's figure out which one we forgot. Basically, the problem is that we have to use less memory, and CUDA's not very good at telling you how it uses memory. Update device mapping info. Oh, I don't think we forgot one. I think that's a new one. All right. So this allocates 50 megs. Oh, but look, it has different flags. Should we figure out what the flags are? Does that sound like a good use of time? All right, heights and widths are stupid. I didn't even realize that the stream was going to be this today, but this is actually going to be useful if we can figure out how to reduce memory usage of the things. So these calls are being generated by the CUDA runtime, which unfortunately is out of our control. But an interesting thing is that the CUDA contexts are different sizes on different GPUs, which makes me think that you want to do run sh grep md? Yeah, we can do that. Yeah. Cool. So now we understand the memory. Actually, let me just add something else to this. there's a CUDA API to get the memory used. So we can print it out here. It's CUDA get mem info. This is it. Free byte and total byte. Always put some 0.2s on your Fs, otherwise it's offensive. Okay, so we have 491 megs free. That doesn't sound right. I have a huge GPU. Oh, no, sorry, used. It's doing that with an XCRM control. We can't actually put that before context creation, but we can put that before malloc. Oh, okay, these XCRM controls are not happening as part of the malloc, but so you see, before we even, like right now we're using 213 megs, but before we even do anything with CUDA, we've already wasted 200 megs. Taylor Swift gave an NYU commencement speech, and I was sadly disappointed. You know, you guys know I love Taylor Swift, right? I'm a big Taylor Swift fan. I think she's incredible. I think that she's managed to redefine herself as many different things. I aspire to be more like Taylor Swift. I'm not like ironic. Like, I think actually Taylor Swift's incredible. Like, she sang like country music, and then she sang pop music, and then she sang like folk music, and I just wish, Taylor Swift, that you weren't so serious about your copyright, and we can all listen to your music and enjoy it together. But why do you care? I don't understand why these people care, man. Why doesn't Taylor Swift open source all her music? You know, like, what's gonna happen? You're still gonna be a huge celebrity. You're still gonna get paid so much money. Like, you just won't make money selling the. It doesn't even make sense. No, I don't even get it. Like, Taylor, this isn't where you make your money. Sell like perfume to young girls. Get the Swift life back online. Taylor Swift had a social network called Swift Life. Okay. So what do we want to look into more? But actually, I don't really care how the CUDA stuff works. I know I promised that we were going to make that work, and we still probably should. But let's look into this RM control. Let's see what it is. Control sounds good. That sounds like something serious that we should understand. All right, so here we go. We can just go. Oh, man, thank you, Nvidia. This code's actually super nice. I appreciate you. I appreciate you. All right. Why is that a different NVOS? Oh, okay, that's fine. This goes here. This is an NVOS 54 parameters. Was it the length, maybe? B8. No, it's not the length, because the length's not 32. That's just unrelated. All right, cool. NV control device only. I don't understand why my back button doesn't work. Do I not have sensible side buttons? I do. I just don't understand why it doesn't work. All right, fine. Data size equals size of that. Here. Control with secInfo. PARGs. Control with secInfo. Oh, yes. We love going 7 layers deep into crap. I don't know. Let's just look at the type. Whoa. This is an NV04 control. All right, not bad, not bad. Okay, now we can just say like command is, what's a V32? What's a V32? I don't even know. Command, flags, params, none of that seems important. Handles don't seem to, well, we can just do it. Client, object, command, flags, all right. P, oh, I shouldn't call it PAPI. How about just P? P.h client, P.h object. Oh, do we have to deref P? No, we don't. I don't know. Is that all right? I don't know if I need to deref it or not. We have to deref it. I thought we had to deref it. I already typed a bunch without it. George, how can you not know if you're going to deref it? Yeah, I could think about it, or I could just type. Oh, cool. Look, these things are objects. Yo, we're getting objects. Wait, is this returning me an object? Oh, maybe it returns me an object. Don't be an object. Does it return an object? I forgot. Looking at the functions was useless, and we just have to look at the thing. You know the thing, right? Alex size. We're doing Alex size? Yeah, we're doing Alex size. Okay. Does it return an object? Handle is memory. Oh, that's memory. Okay, cool. Yeah. So let's move this up here. Run first, and then we can print H memory here. Okay. These numbers don't look like these numbers. Oh, some of these things are owners. Oh, that could be an owner. I see. All right, so these things are called handles. And we don't really know what they're handles to right now. We can pass these nice commands in. Let's throw an 8 on that. Okay, we have client. We have the C1 doobie. I see that that's the same client used in a lot of places. An object here. This must be the get memory command. Where are all those listed? RMAPI deprecated copy out? Like we can find out, I'm sure we can figure out somehow that this is a get used memory command. Okay, it's hard to find through here. NV4 control with sec info. So now we have to figure out where this is set. It's a lot of work. Let's define. Here we go. We don't want to use any TLS. What, thread local storage? What? Here we go. And now we dive in. Ooh! How do I enable that? It's got to just be some way to enable that. Level info. Level. How do I enable this? Does anyone know how to enable this? Probably just some like proc flag. There's got to be some global variable named level somewhere. NV debug level, maybe? No, it's not that. You guys see, like, if we can just enable that, we can get a lot of great logging for free. Whenever you can figure out how to enable their logs, do it. Use only an NV log. I don't know, it's not that level, okay. It's not a global variable, my bad. Printf level enabled. Oh, here, NV printf level. That looks global. Define NV. Oh! NV printf enabled. How do I just enable the stuff? So usually they have some... Oh, here we go. I enabled verbose. I thought that would get it. This says it enables it. Is that gated on something? Cur debug level. Ah, here we go, cur debug level. Default to maximum debug level. OS debug init. OS debug set level. How do I do this? Is this where? Resman debug level. Oh, yo. Here. Oh, here. Proc Nvidia driver registry. All right. Binary. AGP, man. Resman debug level. I mean, I feel like maybe I can put it in that mod probe thing. nvreg_resman debug level? Oh, yes. It did already say that it was maximum. Oh, maximum the other way. Okay. All right, should we reboot? Do we want to reboot? Or are we going to regret that? You know what, boys? We got to just do it. We got to just reboot. Let's just make sure I didn't do it wrong so we don't have to reboot again. NVCom. nvreg resman debug level equals 0. If you Google something and you get hits for it, all right, cool. Bye-bye. Let's wait for it to come back. All right, well, that'd be nice if that just worked. I'll push this code into a gist. This seems like gist code. I think I'm driving to LA today. Can I just unload and reload the module? Maybe. I thought you couldn't do that. I thought Nvidia didn't support that. Oh, look at this. Look at all this debug crap. Okay, 0 might have been too aggressive. Debug mem info. Oh, that's 0. Okay, never mind. 0 is too much. Too much debugging. Do you want to try unloading that? No, nothing replaces what I've done so far. Don't worry about that. We're going to see what we get. And maybe it'll be good, and maybe it won't. The really nice thing about what I've done is it just works in user space, right? So you can just LD preload that into anything and get all this beautiful NVIDIA debugging information right at the API between the kernel and user space. And here's the thing about the API between kernel and user space. It's a real API. So you can't really cheat your way around it. I mean, like, you can memmap IO, but even memmap, you gotta go through the kernel at some point. If you'd like to talk to the world, you must ask the kernel for permission. Well, actually, there's ways to not ask the kernel for permission, and those are good secrets, but you can, like, use Tempest to get out. But it's because you asked the kernel for permission at some point in your life. Well, I didn't mean to do that. Okay. Ah, wait, what? There's still too much crap. It didn't even change anything. Did that even work? Resman debug level equals 1. There's got to be some live way to change this stuff. Nope, I don't think so. Okay. Why is it called close a bajillion times? Look at all this debugging stuff. It's too much. don't know what those are. NVAlloc pages. Okay, that goes real low level. It still doesn't have the thing that I want. Opening GPU with minor. It's not even useful. This is not even the thing that I wanted. What is resman anyway? Let's see what other NVReg options we have. This is junk. I liked my stuff better. How come it didn't print the one thing that I wanted? Which was the control thing. No, we have to go back through this because I didn't save where it was. Or maybe I control second. This, why didn't it print this? How come you don't see that anywhere? Level is info, which is 1. It's not this. No, sorry. It didn't print this, and I wanted it to. So this must be a different thing. NVPrintf. For some reason it's NVPrintfX, but this should like be fine. Module level format, NVRM print function. NVDebug printf. Okay. Fine. Wait. Debug level here. NVDebug level to platform. Oh, port debug. What's that? Port debug. Is this a different debug? Which one did I add? I will briefly try to reload the module. That's resman debug. What about port debug? Port debug? Debug level? Okay, sensitive? No, just resman debug. It didn't even print the one thing I wanted, which was this. NVRM trace API. Oh, how do I use this? It's not a unit test, so it's NVDebug printf. We're back to this thing. Here's debug level. Okay. NVDebug level to platform level. B force. Oh. Wait. Is this just set somewhere else? Okay, we might just have to rebuild it. Maybe this thing doesn't even matter. I don't even like this thing. Does comment work in there? I hope comment works. Oh, this is not, okay. Don't you love open source though? We can just rebuild it. All right, let's go. Build open-gpu-kernel-modules. Source Nvidia Inc. Libraries. nvlog printf. All right. It doesn't seem like this is defined anywhere else, is it? I don't think so. All right, let's enable this, and let's enable 1. Make modules -j. Okay. Doesn't work. Kernel open Nvidia NVReg. Oh, here we go. Okay, here's resman debug level, but that's not the one we want. I think it's actually just not compiled. What's the error? nvlog print ID? Maybe I just didn't enable it right? Because I don't think it's broken. You think it is? It's all the same bug. Line 145. Okay. And not defined nvlog parsing. I think we want that. nvlog print ID. What is this supposed to be? Print ID 0 undeclared. Where is it getting 0? Oh, is the problem that the level has to be... Oh, that's also failing with 1. It's not just 0. Maybe it is just 0. All right, let's try nvlog level 0. Okay, it doesn't work. Same issue. Okay, it builds if I turn it off, and it doesn't build if I turn it back on. Let's Google this. Let's see if anyone's had this before. nvlog enabled. Nope, absolutely nobody's ever Googled it before. If 0, most of nvlog will be compiled out. nvlog print ID 0, not defined. Why not? The compile is being compiled for the parser run. All right, well, this is an NVPrintf. Okay, we are when we get this to work, none of this is actually built into the driver. Actually, we can even confirm that. You want to confirm it's not being built into the driver? We can go. What is it? Lib modules. Lib, what is it? Modules. Kernel modules. I don't know how this works. Find grep Nvidia. Here. String star grep. We'll see if this is actually being compiled out. No, it's not. It is in here. It is that, right? Yeah, param size, that's right. So I don't know. Oh, and we had to build it with that verbose equals. We built it, no, sorry, we built it with debug equals 1. I did build it with debug equals 1, right? Or did I build it with nv verbose equals 1? That's unrelated. Okay, so that should have built it. Yeah, okay, it's still there. This also enables various debug log messages in the kernel modules. Let's figure out what that debug flag does. Let's read the make file. Why do all the first-time chatters ask the stupidest questions? On debug. nvmemlogger. Why do you guys come in and think it's funny to act like an idiot? You know? Why are you here? Go home. Goober never went home. All right. Here we go. If eq debug equals 1. If eq debug equals 1. Okay. Great. It builds uncompiled shit and sets strip command equal to true. You get it? It's funny. Because, yeah. All right. NV separate debug info. No. I don't know. All right. NV printf. Do NV log printf or NV printf string. NV rm printf function, which has to have NVRM defined, which I don't know if we define that. RM always has NV debug printf. All right, we're here again. Here. If NV debug print message, debug level minimum. Oh, then it will print error notice. Oh, is level notice? What level is notice? Level notice is 2. You want to just hack something? I have an idea. If we just change that Let's figure out where debug level min is actually. All right, fine. Debug level here. Debug level less than debug level min. Hide. Message is filtered by an explicit RM. I want to do some. Let me just hack that. If I just change that to. All right, if this doesn't work, then I don't care about this API anymore. Notice. I'm just going to change notice to info. Does this work? tinyvoice work. You saw the work in tinyvoice, but now we're looking into Nvidia open source drivers. Oh no. Are we chanting log levels? Yeah, we're chanting. Let's go. All right. Twitch, CUDA example, dmessage. Oh, those look like a lot of good. I don't know. No, none of it outputted a shit. All right, never mind. That didn't work. That didn't work. I'm just frustrated because there's good debugging information and we just need to get it. All right. Message is filtered by an explicit RM message rule. Oh my God, this is so complicated. How do I set these rules? Where do these rules even come from? Default to everything. Where does this come from? Handle the normal case quickly. Where's RM message come from? Buffer to store RM message string. This is stored in BSS, so it can be uploaded in the debugger. Okay. Override priority of printf. Oh, look at this. Oh, yo, we figured it out. Enable all printfs. We just got to throw a colon in here. How do I set this? OS read registry string. RM message. Oh. Only for builds with printf enabled. Okay, we're going to try one more thing. Well, first off, that didn't do anything. So get, oh, okay, what do I want? History. Make modules debug, sudo make modules install, and then sudo depmod. But the real thing that we want to do, don't worry, this is all going to be worth it because we're going to get the best stuff. You know, if you have 7 hours to chop down a tree, you spend the first 5 sharpening your axe. All right. So I don't know what resman is, but if I set RM message to quote, oh, I think this is it. We're going to be very happy with this choice. Yeah. Okay. Quote. All right. Last reboot. All right, so let's try to figure out how to unload the module. Reloading NVIDIA driver module. It doesn't work. Reset driver without rebooting. Sudo rm mod Nvidia. Oh, this guy tried. No, I tell you, it doesn't work. Many kernel modules can indeed be reloaded, but this does not apply to graphics drivers. Yo, good thing I'm not streaming on that computer. They pushed like 500 functions into the firmware before open sourcing the driver. But to be fair, like, you want to have as little as possible in your kernel, right? You don't want to put shit in your kernel. You'd really much rather be in user space. So I don't really blame them for that. Like, if you can push it into the driver, do it. But the real thing I want, what is that thing called? The GSP? Is it the GSP? Yeah. Whoa. The GSP is the future. All right, listen. I bet there's a way to like boot Linux on the GSP. And then you could have Linux running on your GPU, and you can just have a computer that's a GPU. Think about how crazy that is. And it's RISC-V. All right, did we get the messages? Oh, look at those messages. Oh, these are the nicest messages I've ever seen. Oh, was that worth it or what? Oh, look at how nice those messages are. Twitch, good example. SaxPy. Oh, look at how much better these are than the other ones. All right, here we go. These are the ARM. Oh, never mind. These are equally useless. I was excited about them, but then I read them, and they're useless. But we figured out how to enable what we wanted to enable, because this is the thing that we were targeting. But, like, great. Okay, don't tell me what the command is. Great. I had that same crap from mine. Why did I waste time with this? Why did I waste time with this? I gotta eat food. I'm hungry. Alex, we need food. You learn more through failing. That's true. Does it use more memory because I enabled this stuff? I feel like it does. Control complete. GMMU walk CB copy entries. The other really nice thing about these injectable things is like these are prints from the program, so we can like look at what the program's doing. All right, should we try to figure out what these commands are? It seems kind of useful. And what are these objects? Is there ways to like dump this stuff? Alec with secInfo. Didn't I do the Alec? The RM API. Oh, are those? Okay, we have Alex here. All right, let's parse this Alec. Okay. We have two kinds. We have the PAPI and the PAPI access. Let's just add the code to parse this quickly. These are NVOS 21 parameters. Wait, how did I get 21s? Oh no, that's ALEC memory. This is just ALEC. Not to be confused with ALEC memory, which is another one that we're using frequently. Should we parse ALEC or ALEC memory? We'll do them both at the same time. All right, ALEC memory uses this thing. Is it this thing? NV ioctol, what? Oh, it includes an FD. This is a wrapper. Wrappers. RM API deprecated with secInfo. Oh, well, if it's deprecated, definitely don't want to use it. It might go away. Hroot, limit, stat. Does this look like an ALEC memory call to you? P memory, limit, hroot. What are these things? I don't know, let's just print the hroot. P memory, limit. What's limit? Flag, status, I don't know, let's print P memory and limit. Maybe it's a pointer? That's what P stands for, right? Well, it's the same thing, that it's the same owner as this. H memory. All right, let's go back to parsing RM ALEC. We can understand it. Oh, it's like the same crap. ALEC params. Oh, if you like rights. Parent handle, class num, ALEC params. I hate all these. These are useless. Let's register FD. Lock RM API. There's already a control FD registered. Get the file, release the API lock. They seem to be in the source. Go up for the command hex codes. Okay. They're not. Just 84 maybe? The 84 is good to be. Oh, surprising amount. Well, we can just figure out. Okay, should we go back to RM control? Control with secInfo. Control with secInfo. Oh, God. Oh, generated? Is that these things? Are these method IDs the things? You like this one, you're saying? Oh, here we go. GPU get virtualization mode. Oh, maybe the 20 is extra. Maybe I just do this? No, not this one. No, not this one. Okay. Let's figure out where this is used. Nowhere. Fin. There's also some here. Whoa. It's a lot of stuff. So complicated. How are we ever going to run? You know what? We're not even up to running anything, because running anything somehow does it through a magical MMIO. The only way we're going to get that is with GDB. C GDB add breakpoint. Now, how do I build something so it has a trap? C function GDB trap. Raise exception. Does anyone know how to do this? This should be a very easy thing, right? I just want to I want to stop right here. You know, I can do something stupid like this. Get PID is not defined. What? Where's get PID defined? Well, if I do this, a uni STD. We can do GDB saxpy. Now we can do break on getPid. Okay. Oh, I think that's actually, never mind. It's using getPid. Built-in trap? Oh, is that what I want? Illegal instruction, okay. GDB saxpy. Sigil, illegal instruction. No, it can't resume from the trap. You have to be able to resume from the trap. I mean, we can always just call a stupid function that like nobody would ever call. A to I. That one's in stdlib, right? Oops. No, that didn't work. Changing rip, okay? Built-in trap was the closest I've seen. Here to abort the program. Oh, add built-in break. The optimizer, what you want is built-in breakpoint. Debug break, huh? Oh. Looks like a Microsoft-only shit. Debug break is undefined. Linux. It's our portable equivalent. Raise sig trap. Oh, we just got to raise a sig trap and include signal.h. Oh yeah, we can just raise any kind of stupid, right? That should work. It's a trap. Okay, cool. Yeah, Azimuth 3. Well, actually, if I do Azimuth 3, what I really want is something that'll run normally if a debugger is not attached, and then if a debugger is attached. Yeah, okay, never mind. Do the semicolon. Run. Okay. Oh, yo, let's throw some G's on that. We need a G. You know a G? Gotta put a G in there. It's supposed to be fun, turning 21. Okay. Dim 3 shit. Dim 3. CUDA push call configuration. pthread once. CUDA RT. Oh, look at this stuff. What are these things? This must be what's actually like. GDB macro print all function calls. No. Trace function calls using GDB. All right. Oh, no, you gotta do it on each function. That's terrible. If you can guess the page and unmap it, ooh, I can trap on the I/O. Oh, I see what you're saying. We could do that. All right, so let's just like document this. Why is AMD so reluctant? You know, we have this thing at Comma where it's like, I want you to put yourself in the shoes of a company, right? Well, here's one hypothesis, is because AMD is evil and hates you. Here's another hypothesis, because it's really hard and they've done the math and it's not worth it. Which of these do you think is more true? Wow, 530 takes a long time. 567. Thanks, Nvidia. You really gave these great, useful names. Oh, this is inside that. I don't want to put myself into the shoes of a soulless entity. See, if you weren't a subscriber, you'd be banned. Corporations are people, my friend, and people have souls. Did Mitt Romney lie to you? I'm drinking coffee because I'm hungry. What can I say? Can I say return? No. That returns now. How do I jump to the end of the function? Step to end of function. One day I'll learn how to use GDP. Finish. 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 Oh, no, I finished too much. Oh, here we go. Device stub. Oh, This might be a real thing. How do we, okay, you know what? Let's just try to use the built-in debugging stuff. NVCC debug C. NVCC-V. Man NVCC? No manual engine. Help. There's a way to just like generate C code, is there not? Device debug. Let me see. I just wanted to, you see that temp file that I printed? Here we go. Keep. That'll work. Where's this? Oh, maybe it went in this directory now. Oh, look at that. Uh-oh. Okay. Git init, git add sniff.cc, saxpy.cu, run. Git commit. Good. It's a new computer, I told you. Okay. Wow. Here we go. CUDA push call configuration. And now we found out where it is. It's here. Device functions. Here's saxpy's not even here. Well, this is like the data. Right, cool. What's an II file? Not something we want. All right, we're in CUDA FE stub. Okay, we're in device stub. Okay, here we go. Look at this. CUDA launch. We can probably like write out this stuff manually and then figure out what's going on. But the problem is this includes all the Alright, first let's make this less ugly and not print everything everywhere. Actually, sax. No, I can't do dot star. S trace is what? Oh, just remove all this crap. Okay, cool. Let's cd build cd dot keep slash. Thank you, hype. Build, and this will just be build saxpy. Okay, cool. We're gonna git ignore. Oh, we don't need this saxpy anymore. Git ignore. You know what? Let's put sniff.so in build as well. Should we call it out? Is out a more appropriate thing to call it? Yeah, probably. We can git ignore everything in out, git rm build, run, great. We have all this stuff in build. Terrible. What's a PTX file? Oh, okay, this is what it actually, this is the CUDA assembly file. Cool project to trace a function call. I mean, regardless, we don't actually need this right now because we found out where the missing stuff was. I don't even need GDB anymore. We can get rid of this sig trap. This is stupid. Okay. So the stuff that's being run is, what's CUDA FE? CUDA language front end. So NVCC is like a full tool chain, and there's actually a lot of open source parts of it too. Save temps is an alias of. This unit is so big. Are we really SM52? It's not the latest. We can get newer ones. So what's getting transferred to the GPU is kind of my question. Is it this? No, I found like a... It's a Kubin. It's a fat bin. Useless. I gotta make some food. I'm gonna make some tortellinis. Maybe we'll take like a 20-minute break, 15-minute break, a little quick break, and then we'll come back to this. All right. Talk about two JITs, PTX and not PTX. All right, so what we're gonna do, we're trying to basically figure out how to launch an NVIDIA program without requiring any CUDA user space. So we can just directly use the, we're linking to the CUDA user space. Actually, I should be able to, there should be some like verbose things that I could pass to MVCC. Verbose? Yeah, cool. So that's a cool thing to pass on to. All right, so we see what's actually happening here. Returning sax pi. Is this really what it does? I don't know what CICC is. Not anything I have. What are you? It's the jankiest program. All right. We do the tax ass. I actually know what that one is. That's an assembler. We create the fat bin. What is this with crappy includes? And then this is what finally builds the thing. Look at all this we're linking to. Those are the things that we have to replace. What is CUDA RT? Useless. Tap and hold to record or send audio. I was going to pause streaming for a little bit and make myself some leanies. Okay. Give me a little bit. We're gonna come back in 15 minutes after I made some food, and then we're gonna get to the bottom of this. Wait. Let's allow everybody to talk for a minute, and let's see. Does everybody understand what we're doing in this stream? Not everybody, but the people who aren't idiots. You missed the start. We compiled the fix the rattling sound. What's rattling? You don't know what a pointer is? Oh, bro, you gotta know what a pointer is. Please watch this segment to understand. What is this segment? Yo, this is so meta. We're watching my stream on my stream. I'm going to try to figure out what these I/O control. Okay. We have a goal for the stream. Let's discuss our goal for the stream.
our goal for the stream is going to be to do a CUDA operation from a C program.
Yeah.
So instead of using all of NVIDIA's stupid drivers, we're going to try to not use the drivers, and we're going to try to...
wow.
Yeah.
Wow, that guy makes so much sense when he talks. No, we're not trying to make any... No, we're trying to, like, get to the bottom of what CUDA's actually doing. So then because when you understand every part of the stack, all of the problems you can debug. Like now I know that my RAM's getting allocated on vid heap control. Oh, we can go even crazier with this. So like actually I really like that I have this tool. I'm gonna start using it at work. Let's just improve this tool a little bit more first. I don't care that much about the launch right now. If you can read this code here, this is saxpyku. Should I push? Let me push this somewhere. Okay, CUDA example is a terrible name. We're going to rename it to CUDA ioctyl sniffer. And this isn't called tiny because this is actually a useful project. This can, well, snip.so can just get RM'd. Git ignore. We can git ignore this and all the swaps. Late to learn to code. Yeah, bro, your life's over. Bro, if you don't have 50 years of reverse engineering experience by the time you're 20, oh, you're done. You're done. Bro, we're not hacking Nvidia. They open source this for us. All right, we're gonna have to. Let me create. I'll do it off stream quickly and create a repo. Oh, okay. We have one more thing that we wanted to discuss. All right, so like I have this blog, and a lot of people on Hacker News like to read my blog, and they like to hate on my blog. All right. So this is my blog. It's very short. I just had a nice conversation at work talking about how I think our, estimate for the flops of the brain might be kind of high. Because when you stop looking at the brain as in it's firing every neuron all the time, the brain's actually incredibly sparse, and you can measure it by firing events instead of by total compute complexity, right? So I assumed that each synapse was basically a multiply accumulate, right? So the neuron is like the accumulator, the synapses have weights, and they're all multipliers, so each synapse is doing a multiply, the neuron does the accumulate. This is the basic model of what a synapse and a neuron are. Is it exactly biologically correct? No, of course not, but I think it approximates the compute. It might be off by a factor of 10, but I would be shocked if it's off by a factor of 100. Now, that's these people. These people, lots of assumptions here. Like, for example, this. Human neurons are not built like we build the artificial neural networks. They have a complex time-based behavior, memory, and dendrites are quite complex. Okay, this comment's okay. Actually, these comments are okay. But then you have these comments, the hater comments. Geohot is a good example of a smart guy falling for the old map and territory fallacy. We all use simplified models. Like Steph C int 13. The fuck is this, man? Like, I think he likes the attention and knows many of his claims are half-baked, but yet I think he can do better. I don't think flops is the adequate network for enabling how close we are to the number of neurons firing doesn't matter, but it matters how they're all connected. I personally think when we get adequate algorithms and data structures out there, they switch to a number of lookup operations. Okay, so you think it's RAM, right? Fine, great. I believe that we are yet to observe how interconnections within brain matter. See, it's all just like, where's your blog with your theories on it? You don't have a blog with your theories on it. That's what I mean. The architecture doesn't matter? What are you talking about? The belief is just a brain simulation made of nodes and links is cringe, man. Oh, yeah. Okay, you know what? These comments upset me less now that I'm rereading them. Maybe all like the hater shit all really did get downvoted. Wait, did he mean that? Seriously? To me, this reads like satire about extrapolation. But no, it's a real claim, bro. It's a real claim. It's so much easier to tear someone else down than to make your own thing. That should be the slogan of Hacker News. Hang on. So I'm just gonna go and edit Hacker News here because I'm making my own thing here. Yeah. This is hard. Oh no. I don't know how to use this. It's like in like phone emulation mode or something. Like I was testing stuff. Here we go. This. That's big. Alright, cool. Hater News. Alright. It's Hater News, man. We changed it. Why is it? Hater News. Oh, this is too hard. Never mind. But the moral of the story is you should engage. If you think that I'm wrong, instead of telling me I'm wrong, you got to give the correct answer too. Because I did put maybe here. It's maybe. I don't know. Maybe I'm wrong. Maybe I'm right. As you can see at the bottom of my blog, it says, a home for poorly researched ideas that I find myself repeating a lot anyway. But no, that's probably right. So there's that. All right, good. And then also I'm going to respond quickly to comments. Let's look on comments. Let's see if anyone wrote any good comments. Thank you. Oh, software development is a category on Twitch. I heard about that. We don't need a language model. We just need more data. Oh, guys, should we use this? Sorry, I'm hungry. I gotta eat food. My rant about haters wasn't very good. I'm sorry. I apologize for my bad rant about haters. There weren't that many haters. I'm glad that you all like my blog post. And you always remember that everybody who comments on the internet is mentally ill. No, think about it. Do you comment on the internet? And I know that everybody who says yes in chat is going to be like, yes, I comment on the internet, and you also speak in chat. But 95% of the internet doesn't comment. And they're the sane ones. Everybody who comments has mental illness. So we think that the world's so mentally ill. We think that there's all these crazy people out there. There's all these people on Twitter talking all this crazy shit, man. But then there's lots of normal people like me who quit Twitter when they realized that it was a toxic cesspool and would never post on social media ever. All right. I'll be back in 15 minutes. Should we just put let's just go like this, and this. Yeah, okay, well, you can hear me, but you can't see me. Haha. We're going to put text up, and we're going to call the text be right back. Properties for be right back. It's Helvetica. Oh, no, I think I set the color to the wrong thing. Select font. I have an idea. Let's just do this. And then we'll open up Visual Studio Code. And then we'll write be right back here. And we'll make it big. And we'll close this. Making tortellini. Tortellini, is that right? Oh no, I don't want to save it. Let's see if I spelled tortellini right. I don't think I did. Oh yeah, okay, perfect, yeah. Okay. Be right back. Did you all have a nice time debating about whether I was on drugs? Okay, so we made yogurt instead. The tortellini's coming. Oh, I said I was going to push this to get. I'm sorry I didn't do that. Cool. Guys, it doesn't matter what editor you use. It doesn't matter what keyboard you use. You either have skills or you don't. You could give me a Dvorak keyboard and the shittiest, most broken Emacs, and I will still code better than you. Because it doesn't have to do with those things. And everyone who focuses on those things is a noob. And by you, I don't mean you, all of you. I mean everybody who's asking about keyboards and editors. Tortellini's ready. But I don't know where the, oh, strainer. It's not even tortellini, guys. It's ravioli. I couldn't find a tortellini. All I found was ravioli. It's not the skateboard, it's the skater. That's very true. You could give me the nicest $2,000 skateboard, and you could put Tony Hawk on a mongoose from Toys R Us. Skate circles around me. Okay. So where were we in... I did like at least having... What was that thing called? CUDA push call configuration. Oh. Could I do this? this going to be allowed or is this going to complain? I don't understand how this error works. What is it checking? What does this program do? Oh, it multiplies that by 2 and then adds it to that. Okay, so it should be 4. Fine. Error. A global function call must be configured. I think it's just not generating the stub if I don't do that. Okay, is everyone familiar with some CUDA syntax? Do you understand how this works? This is like the launch of your thread group. It's actually calling CUDA push call configuration, and that's calling the function. And where is that function actually? It's a stub here. Yeah, okay, this probably seems right. All right, this is calling device stub. Let's see if we can try. Let's see if we can check it. You think this is going to work? Let's say if false. No, but the compiler is going to optimize and be smart. So we have to find some false that it will never understand. Like if argc is greater than 99. Argc is undefined. Device stub is undefined. Okay. Let's throw an extern on there. Great. Great. That still worked. Okay, cool. Using stubs for, not subs, even though I love you guys, for launch. Okay. Great. So now we're calling into this device stub. That's pretty nice, and that name looks somewhat stable. I don't exactly understand what it is. But all right, so the stub is here, and now we can copy out what it's actually doing. Oh, this is nice. It's almost as delicious as tortellinis. Okay. So instead of calling device stub, what if we go into CUDA launch prolog, CUDA setup arg simple, CUDA launch. Oh, my problem is I don't know what saxpy that is. It might be a different one. So we don't actually want par 0 here because it's just what's being passed in. So we can just see what I'm doing. N 2.0f dx. So this is like just breaking it down to not use the stub. Okay, these things are undefined. Where is this defined? Is it defined anywhere? It has to be defined somewhere, right? Includes CRT host runtime. What? Don't tell me it's in a low. Don't tell me that. I want to use it directly. Still undefined, eh? Not defined, eh? From CUDA push call configuration was defined. Where is this defined? You guys being useful? CRT host runtime. Is that not the one I included? That's the one I included. I don't get it. I included it. Why is this not working? I need to define this too. Okay, that's a better error. It's upset. Ah, okay, I see what it's upset by. So let's just call it float par 1. It's upset because I tried to pass in. Great. Okay. Now we have some redefinitions. That's a different problem. I really don't understand why it cares. Does not include guard in that file? The only problem now is that identifier direct is undefined, so we can gcc ./direct.c, or I don't want to see it, show direct.o. CRT host runtime is not defined. That's fine. We just need to do this. Where's that? Where'd my thing go? Include like normal CUDA. Oh no, there's got to be C++. Oh, fine. CUDA error T is not defined. All right, where's that defined? Could be defined in a million things. CUDA runtime.h. Okay, that's less bugs. Fabs is not defined. Okay, what do we have to include? CMath. Okay, we're down to only one page of errors. Memcopy is not defined. Memcopy is in stdlib. cstdlib. No, it's not. It's defined with cstring. Okay, n was not declared in the scope. That's totally fine. Because we made up n. CUDA push call config. Oh, we need to pass in dx, dy, and shit. Are they floats? say int n float par1 float dx float dy. Get rid of that. Get rid of that. Get rid of that. Get rid of that. Direct. Don't just watch TV. Direct TV. Love ad slogans. All right, saxpy wasn't defined. That is okay. We do have to figure out where this thing is defined. It's in device functions in CRT. All right. No, that didn't work. If not defined, if def cuda cc. All right, we need that. Uh-oh. A lot of warnings. That might be the only problem. All right, fine. We just need to define saxpy. Extern void star saxpy. Identifier direct is not defined. These are pointers. All right. Hillary Clinton was brought up. You get subscriber only chat. And it's just what happens. Identifier printf is undefined. Oh, well. I don't know what happened to that. Okay. Okay. Now we just need to add in direct.o. Okay. We just have undefined reference to saxpy now. That's because it's probably called some stupid C thing. Nope. Maybe it's just this. Am I just linking to this stub? No, I can't be linking to the stub. That doesn't really make sense. Undefined reference. What is it? NM? Is it this? What is it? C++ fill? This is passing in saxpy here. Where is this saxpy coming from? Is it that? Or it can't be the thing with device stuff. Wait. saxpy, oh, again, that's a different problem. Undefined reference to direct. Is this what doesn't work? Why Why is it an undefined reference? I don't get it. I linked to it. Oh, did it not link in the final step? Ugh. Talking with my mouth open like a savage. No, direct is included there. Yeah, subs are way better people than non-subs. Okay, I have direct.o. Oh, it's just, okay, the problem is it's, yeah. I know what we can do. Undefined reference. Oh! The problem might not have even been external C. It might have just been... Ah, there we go. Done. Great. Okay, notice how it says max error 0. Let's just comment that out and confirm that the max error is actually high. All right, max error 2. Great. Cool, it works. Direct TV. Visa's down. You can't sub anymore. Who broke Visa? Was it crypto? Did crypto break Visa? Not yet. All right, sweet. So that's pretty good. That's actually pretty low level now. Well, I guess we do have the question of like what actually is saxpy being passed into CUDA launch. CUDA launch, Barracuda, what? That's pretty low level. All right, what if we like break it and we set the CUDA launch prologue to 3? Stack smashing detected. Don't do that. CUDA push call configuration, CUDA launch prologue, CUDA setup arg simple, and then CUDA launch with a cast. Do I need this cast? That's a simpler cast. Okay, so let's figure out what saxpy is. I mean, is it C standard int? Is that a thing? How many times I've typed out hex dump in my life? Can you do C standard I/O? That's pretty nice. Okay, cool. So that's the program. That's what's actually in SaxPy. Let's see if that's the low-level stuff. Is that the PTX? Oh, no, PTX is not. No. But we do want Kubin. No, that's an ELF file. So what is this? Maybe it's a section of this file? Maybe it's the FAT bin? No. What is that? What is this stuff? What's being sent into CUDA launch? I don't know, maybe the header gives us some clue? Oh, it's a macro. Look at this macro. Oh, it's actually just calling CUDA launch kernel? That's not exciting. We could have just called CUDA launch kernel ourselves. Wait, what a scam. We actually totally could have just called that ourselves. This is stupid and not low level. They just popped the call configuration off the stack here. Stupid. Stupid waste of time. Arg's IDX is 0. Then do that, which is basically the same thing as, I don't know. Does this just work? Fun was not declared in the scope. Yeah, because we gotta do SaxPy. Great. So it turns out we didn't need any of this. And we actually just could have, I don't know where argzar comes from. Where does that come from? It's just some like it's some global shit. What size? This was stupid. It actually just calls CUDA launch kernel. And we just could have called CUDA launch kernel here and not wasted anybody's time. Here I thought I was getting some low-level, deep stuff, but in reality, I'm not getting shit because I just could have done this. Great. What a waste of time. But I guess it does show you how cuda's internal stuff works. All right, but now what's inside CUDA launch kernel? I don't know. And then what actually is saxpy? This doesn't tell me anything about what this argument was. Okay. Do you see why we got scammed there? Like, we did all this stuff, and it's actually just in, like, user space code that we generate. So we just could have used CUDA launch kernel the whole time. But now how do we go lower level than CUDA launch kernel? And I think that this might be where the reverse engineering starts. Yeah, I know. Don't you love these names? CUDA RT 616, 656. No, but there is no more I/O controls. There's no I/O controls. I'll show you. Like here is using stubs for launch, right? And then here is examem copy. Like it doesn't do anything. How are there 0 search results? I don't know. You want to try duck? Oh, I knew Nvidia was paying to censor it. That's sketchy. What did that do? Did that download something? I don't know. Why have they open sourced this? Because their stock price is going down. We already covered this. No, they open sourced, I don't know. I mean, there's probably pressure inside Nvidia. Maybe we can all thank Lapsus. Thank you, Lapsus. By the way, shout out to Lapsus. Look, man. The hacking groups that go around being dicks and like you know, stealing. Don't steal user information. Like, this is dick, man. You're just screwing over your neighbor. But if you want to hack into large companies and dump large troves of their IP on the internet, look, man, look. I'm not going to encourage you, but, you know, think about who you're really getting here, right? Right? Think about who you're getting. It's not the engineers. It's not the average people. It's the lawyers. And, you know, look, hey, man, you think this is going to end badly for Nvidia? No way. If Nvidia doesn't nerf their GPUs and Nvidia continues down this path of open source, they will dominate the AI space until the singularity. I hope Jensen understands this. Like, there is no reason Nvidia should lose. Nvidia will only lose if they shoot themselves in the foot. I know they already dominate the AI space. There's a lot of people who are itching to get at them. And if what Nvidia does is like kind of make everything closed source and charge $10,000 for it, then you're going to get people who catch you. But if you open source things and you sell things for cheap, nobody can catch you ever. Okay, so we still don't know how this works. It's got to be something that's mem-mapped in the process. Okay, here's an idea. There's got to be mem-map calls, right? I don't know. I mean, you want to, okay. You want to get down to the levels with GDB? Can we use qira? Does qira work? I feel like qira doesn't work at all, but qira is really what I want here. I'm sure qira doesn't work. My janky install scripts. Oh, there's no way this works. Oh, so janky. Come on. Oh my god, no, it's installing Python 2.7. It's setting up Python as Python 2. I regret this already. This is not going to work. Yeah, I think open sourcing and launching AGX killed at least 5... Wait, AGX? No, it didn't work, and now Python is Python 2. I regret trying to use qira. Yeah, I think the device ioctl can... Actually, that's a good point. Yo, I'm doing this in user space. No, my point is, like, right now, I'm in unprivileged user space process. What can we do with this exploit? I'm sure there's a billion exploits in this thing. Oh no, these things are stupid. These things are stupid. No one wants those. Nvidia's mobile division is fucked. They won't sell me chips. Like, it's just fucked. There's until Nvidia puts the chips on DigiKey, they're not serious about mobile. Put the chips on DigiKey, charge a reasonable markup on them, open source all the data sheets, and you'll win mobile too. But we'll switch. We'll switch. I'll switch off Qualcomm. I'll switch to Nvidia. But you got to make your chips available. And you got to make me believe. You got to make them available for a few years, because no one believes you. No one takes you seriously. If you like gonna put one chip, because you're gonna deprecate it. We're gonna go into GDB here. The pricing, yeah. Okay, GDB step by print instruction. Oh. We do have CUDA GDB also. I don't know if it's going to help. Kind of dumb. What is pthread once? Some mutex thing. Oh, now we're in libcuda. So we're not even in, wait, but how did it call from that to that? What functions are exported from here? No symbols. Oh, just this? No symbols, why don't you have symbols? I see symbols. Yeah, there's symbols. I don't know why NM didn't find them. Okay. There is some lower level thing that's being called into right here. I don't understand why GDB doesn't have a symbol for it. But yeah, okay, this is just the lower level. There's like a normal lower level one that I think that's documented still. Yeah, because, okay, if we did CUDA launch kernel, we don't want CUDA launch kernel. We want to use the, we need something that passes in at least a context and a device. So it's going to be something like CUDA launch kernel. Here, CUDA launch grid async. Here we go. This is the stuff that matters, execution control. Here we go. Here, CUDA launch kernel. I'm not sure that that's actually a function, but okay, let's try to replace it with that. Saxpy. GridDimX. Blocks 00. Thread 00. Shared mem bytes. Well, actually, what if I just do here we go. We're at CUDA launch kernel. What's the API? What's the ABI? Info registers. I'm such a noob. x64 ABI. You'd think I'd know this by now, you know? Is this even only the Linux one? integer arguments 1 through 6. So it's RDI, which is this, okay. Oh, see, this is different. Okay, this isn't the function. Yeah, we're gonna have to get a coup function, but that shouldn't be too bad. Okay, and then we have RSI 1000. Oh, maybe that is that. Is that 1000? Yeah, probably. 2 zeros. Oh, they're ones. Oh, they're not. Okay, they're not zeros. That's obvious. This is just like the normal. This is the normal API still. We haven't even gotten lower level. You know, sometimes people are premature to reverse engineer, and you don't need to be premature to reverse engineer because a lot of things are actually just documented for you. You just need to know where to look. You know, all right, access was on the stack. RSP, GX, okay. 1. Okay, it looks like shared memory is 0. The H stream. So is that a coup stream? Do we have a coup stream? No, we don't have a coup stream. Can I do that? 0. Can I pass in args here and then pass in null? Does that just work? Okay. We have to get the coup function. There's got to be an API for that. Coup function. We might have to do coup stream create and stuff. That's not a big deal if we do. So first off, we don't even need this direct stuff anymore. Let's just get rid of it. We don't need any of this. We do need coup function though. What returns a coup function? Has anyone figured it out? Oh, you can use coup module get function. All right, great. All right, now I just need a coup module. Located in the module. Coup function saxpy f coup module get function saxpy. We're just going to need a coup module now. The name is saxpy. Where do I get a coup module from? Coup module load? Coup module load fat binary. Oh, okay. Well, coup module mod. Coup module load fat binary mod. We have the fat binary, do we not? Where's the fatties at? Fatties, bro. Fatties. All right, fat bin. What's the name of this thing? Fat bin data. Fat bin C wrapper. Fat bin section. Fat bin data. Is it this? No, I fixed that. Oh, I don't care about building direct anymore. Ratios undefined, that's fine. I gotta ratio these fuckers. Let's go. Alright, well, we don't actually need a module. Let's just throw a 0 in there. 0! Didn't work, second vault. Alright. Coup module get global. Return a global pointer from the module. No. Coup module load. file name of module to load. There's got to be examples of this online. Oh, I'm trying to load the current binary. Ah, here we go. Find qbin offset. Wow, this is hard. Oh, this is so difficult. Oh, we have to get the Z. Function 77. That doesn't work, apparently. But maybe that actually... Oh, no, it's just 77 because I didn't set it to 0. Okay, it doesn't work. Why is this so hard? Oh, aligning to byte sequence. Okay. Yeah, okay, here it is. Here's this. We found this. So we actually do need this. Fat bin data. Why doesn't that work? Fat bin data is undefined. Conflicting definition. Okay, it still doesn't work, but it feels like progress. Maybe it doesn't work because the name is wrong. Oh, there's a diagram. Which diagram? Oh, here we go. All right, this is somewhat useful. Give me a function. Okay, good. Cool, it works. That just worked. The reason I know it worked is because the max error is 0 now. Great. Okay. Good progress. Good progress. All right. Now we are really low level. It's hard to get lower level than this. And there's still... You don't need any more of this direct stuff. Git rm direct.cc. Git rm-f direct.cc. Okay, and now we're still at launch kernel. I don't think it goes lower level than this. I think this is actually at the lowest level. We are in libcuda. All right, GDB o'clock. GDB out saxpy. How do I get that other view back up? No, of course, GDB doesn't have a working up arrow. Layout ASM. All right, we're getting specific on the P thread. Oh. Oh, yeah, yeah. You know what? RISC architecture is going to change everything. What is this doing? I just want qira, man. Should we just make qira work? Why doesn't qira work? Oh, qira's still in old Python. It's not even in Python. Like print and stuff. Oh, Qira's not even in Python 3. Someone's got to write good Qira. Qira has the oldest JavaScript. Oh, remember when I was a shill for Python 2? I regret everything. I regret everything. Oh, great. Guys, I gotta go to LA later. I can't just do this all day. I want to just do this all day, but I can't. You got it installed. What does CU launch kernel do? Like, it's not talking to the kernel. Oh. Okay, it is somewhat talking to the kernel, because it's caching some stuff here. Was it always doing that? No, that doesn't even exist anymore. Let's move. That can all stay. This is stupid. I'm just gonna copy and paste this. Get rid of blocks, put that there. Get rid of threads, put that there. Those can go. Those are actually needed. This stuff can all go. Get function. Huh. You know, it's interesting. So this is actually still dealing with the compute cache. So this is going to be in libcuda then. Where is libcuda again? Where'd libcuda go? Yeah, okay. So that's interesting. There's still a lot going on. Oh no, it's not in launch anymore. Moved up to here? Hello.
Hi.
Yeah. We've considered fixing Qira.
Oh, your old,
Yeah, Qira was so good.
yeah.
Well, how am I going to figure out what cuda launch kernel actually does? Okay, regardless, I'm confident we can save a lot of money. When is that thing getting copied into the GPU? Not get function. All right. I'll put stream on pause for 1 minute to discuss logistics. Oh, we have a lot of people here right now. Ah, I'll be right. All right. Yeah. I gotta go to LA soon, unfortunately. So I have to leave you guys, and you know, it's very sad, because we're not gonna solve the mystery today. You know, I want to solve the mystery. Let's see what other food we have. How does cuda? Oh, wait. Do I want the awesome or the peaceful? Oh yeah, I'll have the awesome. No, I'll have the peaceful.
We share them.
Oh, we're sharing them both?
Yeah, this is a sharing situation. It's eggplant parm sandwich.
Did that have sauce on it?
No.
Right.
Good, we're not sharing.
Alright, great. I'll have this one. Does anything show up in D message when I do this? Okay. So, you know what? I have an idea. Someone suggested it earlier in the stream. We'll try unmapping the cuda thing, and then we'll see.
Oh, you're putting it dressing?
Let's see. Yeah, sleep's not defined. What isn't sleeping? Uni STD. We love Uni STD. It's I don't know. Just know that like you got to include it if you want some stuff. Oh, it's not Python. What is it called? It's called SaxPy. Right here. So cat proc maps. Ah, look at that. There's the mapped areas of Nvidia. Is it actually calling mmap Or are those I/O controls mapping it? Okay, so this is a pointer. Oh, they're more NVIDIA controls. Okay, so that's the stuff being mapped. All right, all right, all right. We're making some progress. Those ALEC memory things. Oh, there's also map memory. All right. Let's take a look at map memory. That's what we're going to do. We're going to rug pull it. Think about it. It thinks that it's going to have memory, but we're going to take the memory away. And then it won't have any memory. Then we'll see where it throws an error. Go rug pull. Thank you for getting food out.
You're welcome.
All right, just we'll look at this processor for a minute. But if it's some crappy processor, what RAM does it have? If it has DDR3, I'm going to be upset. SRAM. It doesn't have any DDR. Can you tell me what I'm going to fit in a... Oh, here we go. It does have DDR, but it has DDR3 and LPDDR4. Why did you... Ooh, 16x CAN FD. How much are they? Wait, it includes flex drive and USB. Some guy sent me a processor. How many cameras can it connect to? None. All right, how much do they cost? Are they on DigiKey? Are they on Octopart? Or is it Fine Chips is the new hotness? What? $72? How am I supposed to be able to afford that?
More subs.
No, it's for comma. They want us to use a $74 processor because it supports FlexRay.
FlexRay is like the white whale.
We didn't even get to use the thing that we purchased with our subscriber dollars. tinyvoice is coming back, and it's going to speak like Tucker Carlson.
Why don't you do it tomorrow?
Tomorrow? What time are we getting back?
Oh.
I'm not getting back till 4. It's going to be traffic. I'm going to be tired from sitting in traffic all day.
Should we just take the train? Can we stream on the train?
I don't think I can stream on the train. Kafka can't come with us.
Wait, Kafka?
This one's Kafka.
Oh.
This one's DFT. And this one's Tubby.
Is that don't fucking touch?
No, no, no. DFT is written on the board too. We don't talk about what it stands for.
Oh.
I can tell you later. You know what that one runs. Yeah. The Twitchies don't know.
No. Or used to run.
Used to run, yeah, I know. It's a tragedy. That's what I really should be doing today.
I think so too.
We're just, you know, money's just lying on the ground right now.
Well,
Well,
is it good for all volatility?
we love volatility. Up, down, volatility means win. Only George would buy cool stuff with somebody. Look, I'm trying to deliver a good experience to you, my viewers, because my stock price is down, just like Nvidia's.
Your stock price is down?
No, but I was telling them that that's why Nvidia open sourced the code, is because their stock price is down.
Are they under investigation too?
Oh, yeah, but no one takes the SEC seriously. because they're trying to be nice. When companies' stock prices up, they try to be dick and exploit more. When it's down, they're like, well, we gotta do reasonable things.
Actually,
We're your snacks, right?
I know.
Okay. So what were we gonna do? We were gonna look at map memory.
Can you shill jobs for us?
You want to shill jobs? We can't hire more people. We don't have any money.
Production.
Oh, production. Does someone want to come work at Comma and run production?
And support.
Who wants support? Do you want to ask chat? Well, we'll open it up to non-subs.
Yeah, chat.
You want to come ask them? They can't see you.
I'm almost done eating.
If they can't see you, they can't hear you.
Wait, really?
Yeah. I'm a production and support expert, but he didn't put an apostrophe in I'm, so I don't know if I trust him.
It feels like a colloquial, chill environment.
What do I need to know to work?
I think you need to be a good problem solver.
Hmm.
Rational. Think about how to scale things. Common sense, I think, is a big part of the job.
They can't see you.
Okay, let me put this down.
This guy's a drug dealer and says he knows how to handle production.
I do think a drug dealer, a reformed drug dealer, could be a good fit.
That's right. Shkreli
What's
said.
your profit?
Shkreli.
Tell us about your business model.
Shkreli said he met a lot of good people in prison, and only if you sold okay drugs, man.
I think there's actually.
If you sold crack, no.
Wait, what were you selling?
Yeah. What were you selling? If you were selling like weed, mushrooms, and acid, all right. But if it was crack,
Right in here. What else do we want to say? I'd go with the drug dealer. They've been through tough times and survived. Former drug dealer. Like, were you like at scale drug dealers?
just weed. Yeah, I think that's fine.
I mean, did you get in trouble or you get caught?
Yeah, we're gonna do background checks.
I'm lazy and not very bright. Do I qualify? You should just go away.
Alex, you're missing. Whenever we shill stuff for the stream, we lower the value of the stream.
Oh no.
It's true though. It's kind of like Google added this.
Wait. Are we shilling or we're
shitting.
Oh,
We're
offering
shilling.
an opportunity.
No, yeah, that's fucking. I hate that language, Alex. Look what we're doing.
I know. I just said.
Look what we're doing to these people. All right.
Feels bad, man.
All right. I don't want to go to LA. I just want to stream all day.
I know you do. That's why I said that.
Yeah. Wait, we just got a raid. Wait, Jonathan Blow just raided us?
Oh, I love J Blow.
Oh, all right. Well, then we gotta stay on streaming.
Is he here?
I don't know.
I was just thinking of him.
Oh my God!
What?
Look at our view count.
Oh shit! All right, I'll let you
All
get back to
right.
business.
I gotta stream, Alex. All right, 1,600 viewers. Hello, new people. Welcome in. I'm trying to be the best streamer I can be.
I didn't know that Jonathan was still streaming.
I didn't know either. Yeah. All right. So I'll show you what we were doing. We built the open source Nvidia driver and got it installed on my computer right here. Then we built something to sniff all the I/O controls communicating between a user space CUDA program and the driver. But when it calls cuLaunch kernel, which is the lowest level API you can get to from user space that Nvidia exposes, there's a lot of high level. There's CUDA launch kernel, which is the CUDA runtime. And then there's this syntax, which is even higher level and generates these stubs, and I can't believe we wasted time on it. So when you see here in launch, there's actually no I/O controls. So it must be doing the launch. It must like mmap in. These buffers are called something on GPUs. I don't remember. But here we can look at strace and there's nothing. Let's throw a -f and just make sure. Yeah, so between launch and exit memcopy, which is you see where we actually call cuLaunch kernel, we're not making any I/O controls to the kernel. So there's a question of what's actually happening. And so we added in this while one sleep thing. And we can look at the process here's the process. And we can see that it mapped in a lot of NVIDIA control and some NVIDIA Zero stuff. Wait, even this low-level stuff is NVIDIA control and Zero? All right, well, that's crazy. So we're going to finish reverse engineering the I/O controls and figure out what's actually doing that mapping. So we can see that RM alloc memory is actually happening. Let me just change up the heap control one to not. We don't need this. We don't need this. It's printing too much. Either way. So this is the NVIDIA open source driver. We can look here at escape.c and see what it's parsing. These are NVOS 33 parameters. We're not parsing any 33 parameters yet. So we're just going to go in here and add that. When we shill, we lower the value of the brand.
Oh my god. We're not chilling.
Okay. Here. Let's take a look at these parameters. Now we can finally read these structs. These structs used to, I think, not be open source. So it's really nice that NVIDIA open sourced this for us. Oh, pointer for returned address, p linear address. Oh, we can offset in length too. PAPI is too much to type. We'll just change it to P. P linear address, P offset, P length. All right. Is that something we actually map?
I'm gonna buy ice cream.
Sure. Let's finish my avocado toast. So what's the plan?
You can stay on stream.
No. Do you text him?
I gotta call Rita, see if she answers.
You let me know what's going on. We can end the stream whenever, even though we did just get a big influx of people.
How many people?
I don't know, it doesn't matter. Do we do this to be famous? If I wanted to be famous, I'd just go shoot up a high school. I'm kidding, guys. I'm kidding. That's why being famous sucks, though. That's the moral of that story. Banned from Twitch. Banned. I said bad thing. Banned. Nah, as long as you don't expose your nipples, I think it's fine.
What about in like a non-sexual way?
Nipples? I think they like tried
What
that.
if I print out pictures of your nipples and put them on my nipples? Is it all nipples?
They like tried this on Instagram once, and I forget what happened.
You know I get very upset about that.
This is a politics-free zone.
I don't know why the body is political.
This is a politics-free zone.
Guess we can ban you from this house.
What? Watch me. Right click, ban.
My phone.
Wait till we have the new lock system, you know?
Okay, I think I found another lock by the way.
No, I love that lock.
Okay, it's just cheaper. It's so much cheaper.
How much cheaper?
Half the price.
Is it a slodgy?
No.
I don't like slodgy.
I know, this one is interesting because it's small. We'll look at it.
I don't
later.
trust
We'll
small.
look at it later.
We looked at locks yesterday for the comma office. Oh, linear address might not be what we think it is. Let's just add in P linear address is not anywhere in here. So I don't think that means what we think it means. All right, subs only time. Pointer to return. Map memory. What is P linear address? The MMIO address, where the memory object is mapped. I worry that this might be a... maybe ALEC? We like looked at half of this and then got bored. P-ALEC params. This just creates a handle. There's tickets? We need tickets? Didn't that look like an error? Alright, so that made the 6D object. Okay. Whatever these p-linear maps are, they're not useful. Maybe we want the handle. I mean, this would be my guess, right? It has to be this memory. So what we're trying to find right now is where the control interface lives, right? There's some control interface that's letting the... Let's just do this, by the way. I'm just going to set this here. So I do have 2 GPUs. Oh, actually, no, I don't. Oh, wait a second. The question is, what are these things? What does this thing say it is? Okay. 2.6 dev 0 deleted. Look, these allocations don't even last. They're just deleted. Oh, address here. Why do they call it something different on all these things? Okay. The address is nil. PAPI equals function. out returned address. It's always no. Well, some of them have offsets. It's not even the same memory. Oh no, this is generated. Okay, we're getting a handle. Okay, this is being created. The owner is real though. Memory owner ID. Those are not the same every time. Yeah, so no, look, when we're calling heap control here, it's something else. But then we call it on this thing. No, I don't know if the zeros are a big deal, actually. I'm just trying to figure out where these addresses are coming from. See, these are the ones that are really interesting. These ones down here. Because they're non-ASLR. Which is actually kind of crazy. Is it the only one that does UVM? Yeah. Like, I'm just like looking at the proc maps, and my guess would be that the stuff that matters is here. Which, you know, if you want to do any exploits and you want to know something that's mapped at a fixed place, it's a pretty good deal. We can also, there's like, you do LSPCI. Here, look, we can see what's mapped. Which might be useless, but so the mystery now is CUDA somehow is communicating with the driver. So we can just try this. And we'll see what happens. And they seem fixed, so I think we can munmap them. I want to do that before this. See if it listens. Okay, good. See how we got rid of that one? All right, let's get rid of all of them now. wait, we got a segmentation fault. All right. So we got a hit. Sunk the battleship, you know? Bro, watch, we're gonna sink a battleship, okay? Now it works, max error 0. Procpid page map? Nothing there. Do I have to be root to read that? Oh, it's like really long. Okay. Either way, when we unmap that one, it breaks. So there we are. 17 functions deep. That's an exaggeration. Only 10 functions deep in libcuda, we hit a seg fault. Somehow, some way. So you can see RDI is that. All right. Well, here's a question. Where are those things coming from? We can figure this out, right? Is that done with mmap? What's returning this? It's possible the driver's doing it. Also possible it's not. Oh, there we go. This is an mmap. All right. Into why didn't that go into strace out? Like that. Great. Okay. Wait, that's so boring. It's just where it's mapped. So that's how we mmap NVIDIA control, and that's how we mmap 0. Then we open NVIDIA control again, and we mmap it again. And we also mmap it up there. Are these like different regions? Like that one's a lot bigger than that one. Oh, strace-e trace memory. Wow, subscribers are so good. Well, yeah, but that's useless. It's useless because we can't see oh boys, there have to be so many exploits. I can taste the exploits. Okay, wait, but we have this. We have the code for this, so we can just figure out what's being nmapped. We can just read the nmap, right? Nvidia VMA access. I'm the top channel in the science and tech, and this is why we don't change categories. So for people who are new right now, what we're doing is we are diving into NVIDIA's API between the kernel and user space. You can see here when we call launch, which actually launches the CUDA kernel. Look, if you're not familiar with CUDA, you know what? Let's take a minute for the noobs. Let's take a minute for the noobs. I'm sorry if you're not a noob, but we'll take a minute for the noobs. Okay. Intro NVIDIA. Here we go. I remember reading this when I was in college and being like, whoa, GPUs, man, they're going to change everything. Let me explain why. So this is a CPU. This is the basic diagram of a CPU. And this is the basic diagram of a GPU. GPUs have a lot more cores than CPUs. Now, these cores are much smaller. And one of the things that GPUs don't have, CPUs in their cores now spend a lot of time. You know, people think, oh, it's just like some dead simple stuff, and it's an ALU, and the ALU and like what you think of as a CPU is such a small part of a modern core. Most of what's on a modern core is dealing with out-of-order execution. So when you run a computer program, it doesn't actually run one instruction at a time. If it did, this would be horrendously slow, particularly because your memory instructions would take a really, really long time because memory is really far away. I know it looks close, but it's really far away from a CPU's perspective. Remember, that's about how far light goes in a nanosecond. Right? So if you're running a CPU at 4 gigahertz, you can only get this far. And if your memory is physically that is further from your CPU than that, you can't even do it even if you're going at the speed of light, which you're not. But, you know, like you can't even do it in like... Okay. This is a CPU and this is a GPU. Jim Keller's podcast on Lex is great about this stuff. So NVIDIA introduced CUDA in November 2006. And these are, I don't know who did the shoddy graphic design for this, but sorry, I know who they hate, man. I know who they hate. It's just bad. Why does it say consumer desktop and laptop and have a picture of a cop car? Right? It doesn't even make sense. Why does it have a picture of a data center? Who put the car shit in here? Why is there cars? All right. So yeah, this is basically CUDA works like this. You can define a CUDA kernel here. This runs on the GPU. This is how you invoke this CUDA kernel. And it's kind of like OpenCL, but it's CUDA. All right. And this is how things run. You should like read this if you haven't read it because it's pretty good. All right. So recently, NVIDIA open sourced their kernel driver, which is, like how many? I can't even disable sub chat because you all just talk about dumb shit. You talk aliens? You want to talk about aliens? You want drugs? You want drugs? You want to talk about aliens? Right, like this all sound like. Shh. Wait. Is hang on. I gotta just one sec. No, the aliens didn't take me. All right. So, how many of you guys know what a kernel is? Like, do you guys know this stuff? If you don't know what a kernel is, I don't even know like who I'm talking to, you know? Like, you can be honest. All right. So, like, here's your GPU, and here's your kernel, and here's user space. For user space to talk to the kernel, to talk to the GPU, it needs to go through the kernel. And one of the reasons for this is you can have multiple programs in user space, right? So you can have like 3 programs all using the GPU, and it's the kernel's job to figure out exactly who gets how much GPU. It's the OS kernel. So the GPU, basically, you can think of it as 3 parts. It has the hardware, it has the kernel driver, and it has a user space component. Nvidia open sourced the kernel component. The user space component is still closed source. So when we call into this thing called launch kernel, it calls deep into libcuda, which, hang on, give me a second here. We can find. Yeah. Let's add a comment here. So this is in this shared library, which is closed source. Called CU launch kernel. And this is what's actually doing the launch of the kernel. Now, unfortunately, CU launch kernel isn't making any I/O controls. So in order to get from user space into kernel space, you need to do a syscall. This is the kind of stuff I ask in Comma interviews, by the way. And like, I'm shocked that people don't know it. You know, who thinks they're going to come work for Comma and not know what a syscall is? You have to do some kind of trap, which like the kernel is a higher privileged execution, and you do a trap in user space. The kernel says, "Oh, okay, I'll answer your syscall." Blah 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 blah. So these things that we're sniffing right here are I/O controls, and I/O controls are syscalls. We're not actually sniffing them at syscall level. We're sniffing them libc. It doesn't really matter because they are effectively syscalls. If you want to sniff them as syscalls, you can use this program called strace, which sniffs all the syscalls. So there we go, we run that, you can see all these syscalls, you see all these I/O controls. Unfortunately, they're given stupid, useless names because strace doesn't know about the Nvidia driver. So what we did earlier in the stream was we went through and we figured out which I/O control those things actually were, and then we wrote this little sniffer called cuda I/O control sniffer. And some of the stuff's pretty useful. We do see where all the memory is being allocated. We see a whole bunch of different objects being created. I don't know what ALEC-OS event is. I don't know what that is. Register FD, ALEC-OS event. Register FD, interesting. Interesting. There's like the last 2 we don't really understand, so maybe we should take a look at them. They're doing all this control stuff. But regardless, when we actually go to launch the kernel, it turns out that it doesn't make any I/O controls, and in fact doesn't make any calls into the kernel at all, which means that it's speaking to the GPU through some memory mapped I/O interface. And that's what we're trying to discover right now. Now it turns out if I unmap this one, it dies. This is a dev Nvidia control too. If I unmap this one, it dies also. So we can see what's actually mapped in the program by doing this. You can see these things are mapped, Nvidia control, Nvidia control. You can see if these ones are needed. So we're like playing Battleship right now to figure out which of these mappings are actually needed, and then we're going to try to figure out what the mappings are. And they're just being done with nmap. Weird. So there's not that many of them. So it's it's worth kind of just going through them one at a time. Okay, so see how it finished? That means this one's not needed. Probably. And this one's not needed either. Okay. So those ones are all needed. And we still have one more here. Just dev NVIDIA control. Needed ones. Okay, so now it's seg faults at a different place, at the exit mem copy. Oh, this one is NVIDIA UVM, by the way. Oh, it's actually not one, it's two. Sorry, this is stupid. I should be doing it like this. Okay, so now we're down to only four. Oh, yeah, I could protect them read-only, too. That's actually a good point. I don't really care. Thank you. You know what? You've made a lot of good suggestions this stream. Congratulations. You're a VIP of the channel. That's what you get if you make good suggestions. You make dumb suggestions, you get banned. Alright, let's do prop read. Okay, so no, it doesn't even work if it's read-only. Yeah, that must be the control interface then. That must also be the control interface. Can this one prot read? This one can prot read, okay. Those ones I can't even protect to be read-only. Can I protect this one to be read-only? Now, what we really got to do is just get this in Qira. Good. Those are read-only. I have an idea that like those are the main two. Then there's all these ones up here too. They're only a page. And they're more annoying to find, so I care less about them. Does it read it all? What if I just do write? Okay, just write is good enough for that. Is just write good enough for this one? Actually, just write might not work. An idea if you map something. I don't think that works. Either way, we'll leave it because it works, but. Okay, so these are the control interfaces for the GPU. I have a theory. Nah, part right is stupid. All right, we're deep in here, but the good thing about prot read is we can read it. What do we think it is? What do you think those things are? Other ones here. You could map over them and read them after the call. Yeah, you want to try that? Okay. Let's map stuff there. Flags, map shared, FD0, offset 0. We'll just do that one for now. Seg faults. Seg fault is different from that didn't work. Why not? Oh, we have to unmap it. Is that why? It didn't map. Oh, is FD supposed to be like -1 or something? Or do I have to do map fixed? Cert didn't work. Oh, I think I have to pass -1 in for FD or something. No. Oh, do I have to do anon? Okay, cool. Oh, look at that. Oh, yeah. Yeah, look, it like didn't work. I like broke the GPU. Oh, yeah, look, it's broken. Look at that, it's still trying. It's like, please GPU, do something. And it's the GPU's like, I'm not doing shit. All right. Yeah, there we go. All right, let's see what it wrote there. GDB out saxp. Oh, there we go. Look, it wrote something. It wrote something and it thought the GPU was going to do something. Ha! Yeah, they're waiting for a response. All right. What is that? Is that a pointer? Doesn't look like a pointer. Is that the only thing it did? Does it make it exit memcopy? Makes it exit memcopy, okay. And then it's broken. Oh, I think, by the way, launch kernel is not going to default stream semantics. I think we actually have to do one more thing. I'm surprised this even works. I guess cuda memcopy synchronizes anyway, but there's another thing we can use to like synchronize. Stream management. No. Here, this. Default stream semantics. Yeah, okay, we can pass in 0. So we'll see if it's not actually exit memcopy. We'll see if it's just throw in a sync here. All right, and when we're not messing with the thing, works. But now I expect it to glitch out its sync. Yeah, okay, good. You want to try to figure out, we can figure out what that command is. And I think it actually just... Does everyone know what a pointer is? Oh, look, it did two things. Set this as well. Here's something fun we can do too. Let's mmap this too. Oh wow, that's a big one. Whoa, that said a lot of stuff. Same basic idea. You know we can mmap huge things. You guys know about copy on write in the 0 page, right? If you don't know about copy and write in the 0 page, go take an operating systems course. Okay, look at all this crap being spammed to the thing. So this is NVIDIA 0. I think these are like universal things. What's madvise? Does madvise do anything? I feel like madvise is like, you know, what am I going to do with it? Nothing. No VIP for you. I have the source for the driver. I don't even have Oh, someone tried to figure out cuLaunch kernel what it does? Oh, well, let's see. Maybe this guy knows things. Understanding how cuLaunch kernel works. This struct deals with the cuda kernel, the function struct. This guy approaches it from the other angle, not from the driver. It's pretty cool. Yeah, I worry that all this stuff just isn't in, just might not be in this driver. You know? It's just, what is all this stuff being spammed? Oh, well, here's a cute idea. We'll just add another parameter to the function. Call it Bob. And Bob equals to leet food. And then we'll just stick Bob in here. Fat bin data. Oh. Oh, it got bigger. Can I just do that? No, you can't do that because it's a previous declaration. Blah, 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 blah. All right, now, did we get any lead food here? Wait, it didn't work at all? How come we don't have any stuff? Did they move? Oh, like didn't launch. Oh, I know why. This function. Yeah, because we need to stick a IFPFS. Stick an I there? No. I'm not that much of a genius that I can just read C++ shit like that. That actually worked though. Man, you guys would have been like, how do you do that? How do you do that? All right, I'll just do it then. Let's look in here at that. Okay. Yeah, we gotta do that. Oh, pifs underscore I. No. That was close. I just put the I on the wrong side of the underscore. Okay, cool. And so we passed in a useless parameter. See what's actually going on here. Did we put any elite food in here? Do you guys see elite food? I don't see any elite food. There's no elite food. That means it's just pointers. See what this guy's trying to do. Struct that deals with the CUDA kernel, the coup function structure. All right, access to the coup function structure. Is that a pointer, by the way? I don't know, maybe it is. Argument as type 2, aka coup-func stir. Okay, I mean, it's in memory, I guess. Yeah, okay. So that is what it is, but it's not going to give it to you in the type def. Thank you. Okay, so that's CUDA and that's the kernel. So those are those things. But like, I don't know, like that's kind of boring. I mean, we could approach it like that, but that's just, like, the closer you get to the hardware, the simpler I find things are usually. Look at all this crap it's writing. What is all this? Like, these two I understand. It's like some pointer somewhere, but like, what is all this? I guess if it's only reading, we don't care either. Okay, so we're unmapping both the thing here and the thing here. What is the thing here, by the way? It's more NVIDIA control. There is lead food. Where? You found it? Are you a troll? Oh, is it? Did I mess up the? Where? Where is it? Oh! What? It's right there. Yeah, why didn't grep work? Wait, that's highly concerning. Why doesn't grep work? It's probably because it didn't flush. Yo, that's some bullshit. Thank you. Thank you. Grep didn't flush. Nobody flushed their pipes. All right. Wait, so that just worked. Look at that lead food right there. No, that's not VIP. That's not a good suggestion, but I do appreciate you for keeping a keen eye. No. You get VIP if you make good technical suggestions. If you pay attention, you are appreciated as a viewer. And this is what we expect from our viewers. How many do we have, by the way? Wow. Wow, 1,400 people are watching me do this? Why do you care? What do you get out of this? -- line buffered, is that it? No. That's supposed to work. Use non-interactively. Yeah, I don't know. It's like an online co-working space. That's fair. We're all here to work. You wanted to mess with this, but I'm noob. Oh, well, installing the driver is easy. We did that very quickly. Okay. Yeah, I mean, this just must be some like NVIDIA structure that's just like not there. And this is how you launch a CUDA kernel. You're writing those things to dev NVIDIA 0, which is a GPU. That is ASCII, is it not? Are those pointers from... Okay, but look how we've really just nerfed that entire space. Now there are more things up here that it could potentially be using. But I'm not that worried about them. It does seem like that's pretty much the stuff. Should we intercept M-maps? But actually, they're not all M-maps, are they? Huh. Yeah. What is F control get FD? Clo exec does this. So this is like some like, look at this. It opens NVIDIA control. Is there any more NVIDIA 0 or is the NVIDIA 0 one special? Proc driver NVIDIA params. It's pretty cool. Can I change them? Can you go from mmap to a physical address? I don't think that's gonna work. So I'll read this, but I don't think it's in the kernel symbols. Yeah, it's not this, because it's not like, I think that like that's just physically on the driver. I mean, we could figure out what physical address it's at, but I think we're better off just reading the code for mmap. NVIDIA 0 is still mapped up there as write only. There's one more map of that. Yeah. By the way, this is all the crap that used to be in there. This is like all the launches, I guess, in history. What if we leave the mem set in? Does it matter? Wait, no way, that works? Okay, well, it turns out you can trash all those buffers and zero them out. It doesn't matter. So they're pointers. That's pretty cool. Look, I still have it working. I just dumped the whole, I just zeroed out the whole region. I don't even have to map my own. Can we trace the mmap call into the kernel? I mean, we can, but I'm not sure that's what we really want to do. I think that what we're better off doing is reading what's actually getting mapped. And we can just read it. We don't have to trace it. I know exactly where it's going, right? I know which driver it is. It's NVIDIA 0. Yeah, I have to use standard buff, I think, if I want to change that. But, okay. Lead food. I mean, we could just, like, you want to see the mmap? Just see the mmap. The else for this. Oh, look at this comment. NVIDIA device node maps device bar memory. NVIDIA control node maps system memory. Oh, good find. Let's add that comment here. So we misspelled NVIDIA control. Wait, that's what you got? You traced the mmap that fast? I wouldn't even like, I don't even really know how to trace the mmap, but yeah, we found it anyway, so we're good. Okay, if not is NV control device, Then we do this. System mapping code. Else Nvidia mmap sysmem. So this is just like normal system memory. Yeah, just VM insert page. All right. Oh, cool. Yeah, okay, so that makes sense. Is the device bar memory? So we actually know about the device bar memory. How do I, there's a way to filter this. Way to filter that, is there not? Okay. Ooh, it has a resizable bar. Base address register. So is that, it can't actually be the bar memory of the device. That sounds like anybody can break the GPU for everybody else. Ugh. That's crazy. Here's another question. I guess these vid heap controls, how large is this one? Not large. It's right only. Where's the other memory? Maybe it's not mapped. It must not be. So the other memory, when you map memory on the on the GPU, it must not actually like map into your process. Which makes a lot of sense. Like, there's no reason it would, and then, like, it does cuda memcopy. Oh, I mean, I'm interested, I guess, in what memcopy does, too. Okay, this is what memcopy does, and it does it somewhere totally different. It enqueues a kernel for that. What is it?
More exotic flavors. So you want some?
time are we going?
An hour.
An hour still? Do we know about traffic?
Seems I checked.
Hmm.
It's about 3 hours right now.
Oh, this is a lavender cucumber. That's not a real flavor.
They're really trying to make it happen. It's like spa water.
Yeah, it just tastes like imagine getting waterboarded at a spa. Ora Bora. It's like getting waterboarded at a spa. See. Look, it just like uses the next one. I'm zeroing everything out. I think maybe like you don't understand how serious that is. None of this stuff even matters. I just zero it all out. It doesn't matter. I just zero it out. And it works. We should probably like write a better check to see if the program's actually like running. And it's all 0 except for these ones. So it's got to be some like ring buffer structure. I think this is more understandable. Those match. Is this here? No, I must map that in the kernel somehow. Or that's not pinned memory. Oh, wait. I think there's like tricks if we do like pinned. And I know you can do this in Python. Yeah, cuda memcopy. We can get lower level than cuda memcopy. It's got to be like memcopy. Memory management. Here we go. memcopy. Okay, it looks the same. So maybe the pointers are wrong. Oh, we need to pass in coup device pointers. What? Wait. Oh. Did I just break that? They're not really float pointers, are they? What's cuda malloc? Returns a dev pointer. That is not cleared. CUDA free cannot be used with a dev pointer. Can I just like read from that? What's there? That should be mapped, right? It's got to be mapped somewhere. Two 823 823E8. No, it's not mapped anywhere. It's in the nowhere's land. Which I guess kind of makes sense. It just like it doesn't want you actually accessing it. We can try to access it. I think you could just get a fault. Because it's a device thing. Yeah, okay, it's like fault. The problem is, I don't think these ring buffers are implemented in the kernel. I think they're implemented on the device. Like, this is what I mean why I'm not even sure this kernel driver is going to yield us anything useful here. This doesn't look like it does anything fancy. It looks like it just maps the... Like, this is just mapping the page. Which is kind of surprising to me, because how is this shared between... I don't know. Actually, or is that a threat model of the GPU drivers? Like, are GPU drivers supposed to work if, like, multiple processes are, you know, all not cooperating? Like, maybe they're not. But you see what I mean? Why I think it's a ring buffer? Like, I think this is enqueuing something, and this is enqueuing something. And it seems like it's every hex 2000. Then, like, here's another one where it does that, and then it does that. Oh, we can do this too. Pretty useless. I mean, it probably just shows up like when one of these things finishes. This is NVIDIA 0. This is NVIDIA control. Oh, look at this. Look at this. This is a pointer. See? This is a pointer to that. It'll be more obvious if we change the dump function. Okay, I get it now. Yeah, look, they're pointers. They're pointers. That's a pointer to this. That's a pointer to that. Okay. 5C. Oh. This is a pointer to down lower. One of them asking to GPU to DMA to host memory. Yeah. So some of this stuff is yeah. Okay. I'll explain to you how it works now. I think I have a pretty good understanding of it. Well, actually, here's an interesting thing. These are not 64. They're 32. Well, okay, so I'll explain this to you. It's simple. This is dead simple. This here is a pointer, and it points to this. So the kernel must be something like this. So where's the lead food? The lead food's down here. I don't know why it has 2 copies of it. 84 might be the length. But 484, oh, no. Well, that's really long. Look at how long it is. It's from there to there. To 890. Oh, it's all just one NQ. I don't know what that other stuff is. Oh, maybe this is... Oh, boys, I got something. Okay, here's my theory. This is being written to by the computer. Then this stuff is the response from the GPU. How can we tell? There's a kernel thread calling NVQ. Okay. There's a kernel thread called NVQ. Yeah, it's a sort of handshake. Oh no. I don't think any of this stuff's in the kernel. Like, I just don't think the kernel's doing anything anymore. I mean, it probably is. Okay, the kernel's probably listening, and it's probably getting an interrupt. Wait a second. How does CUDA synchronize work? How does CUDA stream synchronize not use any kernel call? There's got to be spinning in user space then. Unless, maybe I'm just not fast enough. Wait, it's actually spinning in user space? Oh, that's trash. But it must be. Yeah. Yeah, there's the launch, which includes a synchronize. It's got to just wait in user space, right? I mean, what else explains this? Like, probably what happens, and I'm protecting it. I'm protecting read-only doesn't work, right? Sorry, I'm protecting so you can't read it. Doesn't work, right? Yeah, it obviously doesn't work, right? Because I just read. Well, that's a scam. Yo, we're gonna write a new CUDA and it's gonna use kilobytes of memory. Everywhere that they used to be using megabytes, we're gonna use kilobytes.
Okay.
It's gonna be unbelievable. I don't know what we're gonna do with all our memory. We're gonna sell it to people. We're gonna sell it to the Chinese. We're gonna sell it to the Saudis. We're gonna sell it to the Israelis. We're gonna sell it to the Palestinians. We're gonna sell the RAM to everybody. Yeah? What?
Are you selling arms to the Chinese?
No, I'm selling RAM. What am I going to do with all the extra RAM? I'm going to sell it.
Well, arm, also spells, RAM also spells arm.
Yo, that's true. It also spells MAR.
Yeah, just be careful.
And MRA. All right, but does everyone see what's going on here? So this is the kick off thing. It writes to 0 and it writes to 18 and like that. And then this is the response from the GPU. See the response? Let's not zero out before the mem copy. And we can see more. Yeah. Response. Okay, cool. You get it? So this is a packet. And this is a packet. This is a pointer to here. So if we just build this struct, we're good. This one kicks it off with a 35602. This one kicks it off with an 0302. Cool. All right. Have you read this one about device synchronization? Let's see. Memory bandwidth. No, I don't know about this. I mean, it looks like we'd have to peg a core, right? The only way to do that otherwise would be like use an interrupt, and that would have to go to the kernel. As far as I know, there's no efficient way in user space. So it must be it must even be worse than that because it's not calling sleep. It must be like a spin weight. Wait, it really must be a spin weight. That's disgusting. Maybe it knows that it's short and doesn't do the spin weight for some reason. Is it doing callbacks? Is there threads? Does this program make threads? Tree. Oh, it has threads. Do they have names? What's F10? I don't have F10. Oh, look at these. CUDA event handler. So hang on. Maybe all we need to do is have a F. Have a... be an S trace with an F. That might have been the mistake. Look at that. See second result on Google. Link it. It's a different result for everybody. Google changes for people. You know that, right? Okay. No, there's still nothing in between launch and malloc. But there might be sometimes. I don't know. Whatever. I don't care about this mystery. On my results. Which, I don't know what you're talking about. Okay, regardless, does everyone understand kind of what it looks like? This is saying run the command stream starting here. Here are your launch parameters. It would be interesting to see which one it writes to first. My guess would be this one. And then here's the response from the GPU saying, hi, your command stream is now here. I did 2 shits and it took 84 little shits or something like that. Now I'm not too good. I'm not too sure on the big shits and the little shits or anything like that. But it's something like that. It's gotta be. Okay. I don't really care about the mem copy for now. So basically, we can comment all this out, and then it'll be upset and it will fail. But if we poke this shit, it should be good. It is the same every time, right? It is always this. If you don't know what a pointer is, this isn't going to make any sense to you. So, you know, you better go study pointers. Where is it seg faulting? Oh, it's not right. We want to add. Okay. Does this match this every time? Or is there ASLR? Sworn enemy of Charlie Miller everywhere. Oh, they're not the same. If this works, we're getting there. Let's just try this. Let's just go. Let's just go. Mem copy. Oh, you know what's so nice about C? You know, you don't have to deal with oh well, I gotta check if my string is encoded in UTF-8. C doesn't have shit like that. C is made by based people, man. That's the real truth. People who made C were based. That's yeah. No, it's true though. It's the only way to describe it. All right, so that should replace. That should let us launch our own CUDA kernel, as long as we don't have ASLR, bane of Charlie Miller everywhere. No one even gets that, but it's true. Argument of type long is oh yes, because that's, you can't just copy to it. No, you can't just do that. You gotta do that. Yeah, that's right. Don't upset the. Oh, failed. Oh. Well, come on, that was supposed to work. Wait, okay, here's an idea though. What does this look like now? It did go to the next thing. Let's not memset that. It must just be something's at a different address. No, it just didn't. I must not be doing the magical incantation correctly. Or, oh, you know, it could be a worse problem than that. It could be worse than that. It's possible that the problem is that the driver is then messed up. You know what I mean? But okay, this should still work if that's the hypothesis. No, but look at how different those are. This isn't going to work. No, look at how different they are. They're too different. So this is the buffer being shoved into the memory and that the GPU is told to execute. And unfortunately, it contains pointers. So, you know, like, you know about like Inception? You see that movie? It's like that, but you didn't make a deep enough copy because we only made a shallow copy. It's like if you only, you only make a shallow copy, you don't make a deep copy, and then without the deep copy, all the deep depth isn't there, and you're left with like, you know, stuff that isn't deep, like kiddie pools. Is my time up? Oh. Well, that one's different, so we can delete that one. They're pretty similar. That one's different. These are different. Because that's the ASLR base. Am I gonna like it? Yeah.
We're gonna see the farm. Rob has chickens, goats, horse.
I'm going to a farm, boys.
In Malibu.
I'm going to a farm in Malibu.
Yeah, Rob's
I'm going to a farm in Malibu, boys. We're not gonna solve the mystery today.
What mystery? Is this like Mike Tyson's Mysteries?
Yeah, kind of. Not really. I mean, we mostly solved the mystery. We got kind of where we are. One of these days, we're gonna write a new CUDA driver, and it's gonna be fast, and it's not gonna use any memory. Why is this using memory? What is it doing with the memory? Oh, you know what's even worse? Some of these probably aren't CPU pointers. They're GPU pointers. Okay, well, we can check one more thing. It's not going to work. But like, eventually we're going to have our own driver. You know what probably understands these things pretty well? Novu. I'm going to go read the Novu source code because they have to understand this, right? Novu is open source Nvidia driver. They have to have these structures reverse engineered, right? What are you making?
What am I making?
Yeah. What are you making?
Nothing. I'm making some chickens. On the couch.
You're eating chippies on the couch.
Don't tell Mom. Some tomatoes.
Yeah, all right.
You want chip?
No. Novu isn't really CUDA though, just graphics, isn't it? Yeah, I don't think they have CUDA. Novu does not support CUDA, but it does support OpenCL. Which one do I have? I have Ampere. No, I'm just saying that, like, this code has to be here, right? What's a GF100? Oh, some crappy old GPU. Oh, look at how old this is. Like, this can't be the real Novo. Novo kernel tree holds the accelerated. This was forked from Nvidia's NV driver. Mesa. any of these. Yeah, but eventually tinygrad isn't even going to use a CUDA driver. It's going to talk right to the kernel. And then it's going to be the fastest implementation. Yo, wait a second. We could actually do that. Think about it. We would have the fastest implementation of neural nets anywhere. Think about it. Look, right now, real talk. Google made a compiler for their TPU that statically compiles neural networks into TPU binaries. There's no reason you can't also do this with GPUs, but Nvidia hasn't done it yet. We could take their existing hardware and we could make it work like a TPU, ensuring Nvidia, no, this is really old too, ensuring Nvidia will be the winner forever. Should we try to support that in tinygrad? Tesla does the same? What do you mean? Think about that. No, we're not the baddies, man. We're here to liberate the world. We're here to give everything away for free. Fast, free, cheap, and easy. Is that what the bad guys do? No, the bad guys are bureaucrats who make your life hard, boring, complicated, and slow. It's true. All right, in this theory, it writes to this one first. I'm sure it does. Yeah, it's possible when you mmap, it just gets like a new page, and then that GPU just like, it's like a control page, and that just kind of works. This stuff has to have pointers to the, it has to have pointers to the code in it. We know that it contains elite food. We found the elite food. The elite food's right there. Oh yeah, and then these are just the other pointers, and then that's that float, is it not? And that's n. Oh yeah. Like even those pointers were wrong. So those are the pointers to the device structures. I think it's 958E58. And 580, no, but that's not the one. All right, we'll be back tomorrow. We'll be back tomorrow to finish this. We are going to launch a CUDA kernel without the Nvidia cuLaunch kernels. And then with our newfound power, we will make Nvidia GPUs so fast because they'll just poke things. It'll just be poke. It'll be like C. It'll be written in C, like fast. All right. Bye, everybody.